Hi everyone, welcome back to the class, and I'm so sorry about the problem that just occurred. I think for everything that is happening good, there has to be something bad, right? So it's just about a little bad luck from my side, right? But don't worry about that because we are going to resume the session as I discussed before with you. Till now, we have completed around 20 questions, right? Rest of the 80 questions we are going to do in this part. So everybody, I want to see your energy. I want to see your Josh in the comment section. So let me know if you guys are ready for the rest of the questions, right? Yeah, something happened and I think the studio went off, right? Studio was like dead, right? Already very confused with the question. So I had to wake up the studio again, but now nothing will happen. Don't worry. I've already talked to the team, but sometimes some technical issues happen, then that is not under our control, right? Okay, so yes everyone, let us start the session, but I want to see the same energy in the chat box. The same energy I want to see in the chat box, everybody. Okay, yes everyone. Okay, so let us see this question here, that is match list 1 with list 2. Choose the correct answer from the options given below. So from the options given below, you have to choose the correct answer. If you see this here, then zymase is going to be yeast, okay? So zymase enzyme is going to be with the yeast. So answer is A2, A2. This is eliminated, this is eliminated. Diastase is going to be malt, right? Then you have urease is going to be soya bean, right? Then pepsin is going to be stomach. So answer is your B3C4D1. So B is going to be the correct answer here, right? B is going to be the correct answer here. Next question, beta, as you can see here, invertase, that is source is yeast, that is there in sucrose, glucose, right, fructose, right, that is used in this reaction. Zymase, that is also source is yeast, that is used from glucose to ethyl alcohol and carbon dioxide. Diastase, source is malt, using starch to maltase. Maltase is from yeast, it is maltase to glucose. Urease is from soya bean, source is soya bean, converts urea to ammonia and carbon dioxide. Pepsin is in stomach, it is used to convert protein to amino acids in our body. Okay, so answer is C. B is the correct answer. Next question on your screen is the number of Bridget. They are talking about the number of Bridget oxygen atoms present in compound B formed from the following reaction. Okay, so they are formed from the following reaction. So this is PbNO3 twice give rise to A plus PbO plus O2. Then A will dimerize to give B. Now they are asking you number of Bridget oxygen atoms present in compound B. Okay, so firstly you should know this reaction. So let us see this reaction firstly. If you see this reaction, PbNO3 twice, at a very high temperature, it will get converted to NO2 plus PbO plus O2. So NO2, it's a brown gas, right? That is how you will get to know about this reaction. This brown gas will dimerize. This will be N2O4. And in this N2O4, the structure, right, very important, that is there in chemical bonding, right? From this structure, as you can see, in this structure, there is one NN bond. There is two oxygen with double bond, two oxygens here, right? With the single bond here. So no Bridget oxygen atom is present in N2O4. So answer is 0 is the correct answer. Next question is, during the halogen test, if you talk about the halogen test, sodium fusion extract is boiled with concentrated HNO3 2. Right, so this question was exactly there in your attempt 1 of JEE means January, right, 2025 January attempt. It was there. They have asked 2 questions from Lissagany's test. So during the halogen test, basically AG test, right, sodium fusion extract is boiled with concentrated HNO3 to remove unreacted sodium, decompose cyanide or sulfide of sodium, extract halogen from organic compound, maintain the pH of the extract. So what is the correct answer? Everybody let me know in the comment section. What is the correct answer, everyone? What is the correct answer? Everybody, what is the correct answer? I'm audible, right? Okay. So what is the correct answer, everybody? Just let me see, right? Okay, sure. I am audible, na? Hana? I am audible now because I can't see your energies in the comment section. That it makes me feel like I am not audible to you. Right? Okay. So yes, everybody, C, B. Okay. C and B is the confusing part here. So during halogen test, what exactly we do? We have the formation of NaX, then we react this with Ag. Then you have the AgNO3, we react this with AgNO3, right? Then you have the formation of AgX, AgCl, Ag this and that. So what we do there during halogen test, sodium fusion extract boiled with concentrated HNO3 to remove unreacted sodium, no decomposed cyanide or sulfide of the sodium. So in the sodium, right, the cyanide and sulfide, we need to decompose it. That's why we react this with HNO3. That's a very, very important step. In between this, before this step, we react this with HNO3 also to extract the cyanide or sulfide present with the sodium. Okay, so answer will be B is the correct answer. Very, very important because they are asking you questions from Lissagane's test, right? Next is amongst the following. So these are the questions here. The major product of the given chemical reaction. So you have to tell the major product here. So for major product, if you see, this is Br2CH3OH. What is the major product here? Again, there will be rearrangement or not. That is a very, very important part, right? Br2 in presence of methanol, right? So let us see what we are going to do here. So basically, whenever you are adding Br2 here, right? So double bond will break. That is the correct thing to do. So this double bond will break and you will have Br and Br on this side, right? So when you are adding Br2, right? So both will be a syn addition, okay? So this will also be Br, this is Br, this is Br, right? So here we have the cyclic halonium ion, okay? A cyclic intermediate has been formed here. Here it should be positive, okay? So after this, what will happen? This bond will break and from the anti position, let us see what we are doing here. We are adding Br2, Br2, then we are adding MEOH, right? So when you are adding Br2 and a cyclic intermediate is formed here, this pi bond will break. You will have a cyclic intermediate here, right? Now, in this cyclic intermediate, when you are adding MEOH, right? Basically, this MEOH is what? You will have MEO negative, right? H positive, right? So, this OMe is going to attack here, negative is going to attack here. Now, because already one position you have occupied, so it will attack from the back side. So, that is why there will be anti-attack here, right? When there is anti-attack here, so what will happen? It will be on the, if this is the dash, this will be solid wedge, right? So both directions are opposite to each other. This is anti-attack. The second one is the anti-attack. So that is why E is going to be the correct answer here. Here basically you have to tell that which will attack firstly on which position, right? And whether that will be anti-attack or that will be a syn attack. So that is going to be, a second is going to be an anti-attack here. Always when you have cyclic halonium ion formation, there will be anti-attack only, right? Okay. Next is at 345 Kelvin, half of the life for decomposition of sample of gaseous compound initially at this was 340 when the pressure was 27.8 kilopascal. Okay. The half-life was found to be 170 seconds. The order of the reaction they are asking you. Okay. So they are saying at this temperature, the half-life for the decomposition of the sample of gaseous compound initially at this was this. So initially, if you talk about the half-life here, so you have to write everything here, okay? So initially the half-life was 340 seconds. Okay, when the initial pressure was 55.5, then when the pressure was this, when the pressure was 27.8, right, the half life was found to be 170 seconds, right, the order of this reaction. So basically they have given you two half lives, they have given you two pressures, okay, two initial pressures they have given you. So you can name it as, this is the first one, this is the second one, dash and dash. So what you can do, what you should know, that T half and initial concentration or pressure are related to each other. T half is directly proportional to Pi, right? This is 1 minus N, right? Okay. So this is the equation. You can take the ratio. They are asking you the order of the reaction. N is what you have to find out here, right? So what you will do here, as you can see here, right? I have told you that T half is directly proportional to P, right? Initial 1 minus N. They have written it opposite, 1 by N minus 1, that is the same thing, okay? So you can also write it as 1 by P initial, this is N minus 1, okay? So now because they are inversely proportional, so I'll just directly write it here, T half dash is equals to Pi dash, right, raised to power, this is 1 minus N, this is 1 minus N. So together we can write Pi by Pi dash is going to be 1 minus N. Okay. So T half and T half dash is already given to you. One is T half is 340, that is 170. Okay. 340, this is 170, right? P initial here is 55.5, that is 27.8. So you can just write here 55.5, 27.8, right? This will be 1 minus N. From there, you just need to solve this value, right? Okay, when you solve this, it will come out to be this, right? Okay, because this is approximately double, okay? So this is approximately double. 2 times, this is also approximately double. So 2 is equals to 2, 1 minus N. This is what we got, right? That means the value of, if we are saying 2 is equals to 2 raised to power 1 minus N, that means the value of this should be equals to 1. 1 minus N is equals to 1 only when N is equals to 0. Here that means the order of the reaction is 0 in this case. Okay, so answer will be N is equals to 0 is the correct answer. So you can just write here, it is 0 is the correct answer. Integer based questions these are, right? Okay. Next is, if you see the delta E by delta T at constant pressure of different types of half cells are as follows. So what is going to be the correct answer? Everybody let me know in the comment section what is going to be the correct answer. Yes, everybody. By the way, where are all the other students, right? Where are all the other students that were there in the initially they were there in the class, right? Where are all those students? Hana? That is how you are going to crack JEE mains, is it? I don't know, they went off or where they are, because if this is the, see, if they are not able to see that I am already in the class, then I think I should again message them. Wait a minute, I am live in the class. Wait a minute. Sure. Okay. So I have texted. I hope so. These students who have missed out, who are missing this lecture, they see this, right? Because I don't want any student, right, to, in the end, they'll be like, oh, ma'am, we were there in the session before, ma'am, but then something happened, then we didn't knew about, you were live in the class. Okay. So I don't want this to happen. Okay. Okay. Yes. Sure. Let us see. Yes. Let us see. The delta E by delta T at constant pressure of different type of half cells are as follows. Okay, different type of half cells. Acha. Okay. Where E is electromotive force, Which of the above half cells would be preferred to be used as reference electrodes? Okay, as reference electrodes, they are saying which will be used. Yes, everybody, as reference electrodes, which will be used here? Everybody in the comment section. Everybody in the comment section. Yes, everybody. So if you can see here, the value of Nernst equation, okay? From the value of Nernst equation, we have to find the lowest value here. Okay, why we have to find the lowest value, beta? If you see this here, electromotive E is equals to E naught 2.303 RT NF log this and this. Now, if you see the variation of electromotive force and temperature, right? As the temperature will be more, if temperature is more, this whole value will be more, right? That means this value will be less. So we can say that E and T are inversely proportional to each other, or you can just directly write it, the straight line graph also you can make. Y equals to, this is M, this whole is M, this is X, okay? Mx plus C. So you can see the slope is going to be, this is the slope, okay? That means this is going to be the slope, okay? This is Y equals to, this is Mx, this is C, okay? So if you are taking X as this temperature, this whole minus of 2.33 R by NF log of 1 by oxidized form, that is going to be the slope. If slope is negative and that is a straight line graph, so that means it is going to be inversely proportional, right? So this is what I told you, that directly also you can say as E increases, temperature decreases, or you can also draw the graph here, right? So that means if we want to have, they are asking you here, watch thing, they are asking you which of the above half cells will prefer use as reference electrodes, right? So E should be, if you talk about that this is the different type of half cells as follows, then that means with respect to temperature, this value should be least, okay? More the deviation between E and E naught, this half cell with least value can be used as the electrode, okay? So we have to find the least value here, right? So if you find the least value, because here we know that pressure is constant at this point, right? So we have to find the least value of this. If you have the least value, that means that will be chosen, right? So if you see this here, the least value is there in this 0.1 into 10 raised power minus 1. So this is nothing but 10 raised power minus 5. That is going to be least value. So answer is C is the correct answer. Okay, understood? Next is the correct order of melting point of hydrides of group number 16. Melting point of hydrides of group number 16. Yes, everybody? Melting point of hydrides of group number 16. What is the answer? Yes, everyone? Yes, everyone. What is the answer for melting point of hydrides? See, if you talk about the melting point, we are talking about the, see, this is oxygen, sulfur, selenium, tellurium. Okay. So, we know that melting point, it should increase down the group. Okay. Melting point should increase down the group. Right. Because size is also increasing. So, melting point also should increase. But oxygen, which is forming H2O, that will have hydrogen bonding. So that is why here the melting point is going to be maximum. So answer will be, first you have sulfur, H2SC, then H2TE, then you will have H2O. That is going to be, because of hydrogen bonding, it is going to be the maximum. That is the exception. So answer is going to be A is the correct answer. Okay, A is the correct answer. Very, very important chart from your NCERT, that this is the melting point order, this is the boiling point order. These two orders are very important. And the hydrides of halogen, the hydrides of oxygen family are very important also. Group number 15, 16, 17 hydrides, and the values of melting point, boiling point, stability, dissociation energy, all of them are very, very important for you. Right? Okay. Next question is, consider the following reaction. So this is the reaction that you have. Now for this reaction, tell me what is the answer. Yes, students, Tell me what is the correct answer for this question. Everybody, consider the following reaction. A plus alkali gives B. B is oxoacid of phosphorus, right? With no pH bond. Okay, that is having no pH bond. Okay, so that is okay. So it is not having any pH bond. Then it is going to be made from white phosphorus, red phosphorus. From which phosphorus? Yes, everybody. It is not having any pH bond. Okay, it is not having any they are not asking you, they are not asking you what is B, they are asking you what is A. What is A? They are not asking. If those who are answering H3PO3, beta, tell me what is the value of A, right? What is the, see, for no pH bond, this is oxygen 1, 2, 3, this will be OH, this will be OH, this will be OH. Okay, so that will be H3PO4. H3PO4 is made from which thing? White phosphorus, red phosphorus, P2O3, H3PO4. H3PO4 is made from which thing? Right? Very good. That is made from red phosphorus here. Right? So answer, you can write it here. That the answer is, as you can see, wait a minute. Right? So this is basically, wait a minute. Let me see. It is oxoacid, B is oxoacid, no pH bond, A, then A is. Wait a minute. We can also write A as red phosphorus here. H3PO4. No pH bond they are saying, na? Wait a minute. Let me see. P2O3 plus water. Here also you have pH bond. No pH bond you have either in this, right? Or here. You have no pH bond. Here also you don't have any pH bond. Here also you don't have any pH bond. Right? Okay. So H3PO4 is made from P4O10. That is so not there in the option. Hai na? P4O10 is not there in the option. So this will not be our answer. H3PO4 will not be our answer. Okay? Because this is made from P4O10. This is made from P4O10. So this is not going to be our answer. Right? The one that is made from P4O10, that is not in the option. So this is option is already excluded. Right? If you see this table, rest of the things are H4P2O8, right? H4P3O7 and HPO3 and N, that is a polymer, right? So from here we can see only this one from red phosphorus plus alkali, you have the formation of H4P2O8, right? That we can see. Okay, understood? Here, what is the structure of H4P2O8? So P2, right? O8, right? 1, 2, 3, 4, right? H4, wait a minute, H4P2O8. H is also 4, P is also 2. So what you have to do, there is no, this will not be the structure. It will have a double bond here, na? Ha. 2 P double bond O, 1 P and 4 POH. If you see 2 P double bond O, right? 4 OH. It is not making, I think there is some confusion here, right? Let me just draw the structure, right? 1 PO. Okay? If you draw this thing here, right? 1 PP bond, let us draw that. Wait a minute. So that is going to be H4P2O6. Okay? Let us see if this is the structure. H4, this is basically H4P2O6. Okay? This is made from the red phosphorus. Okay? With alkali, you have the formation of H4P2O6. So whenever you are drawing the structure of phosphorus oxoacid, now just remember one thing, that always phosphorus is going to have a double bond. Okay. Rest of the things you have to see. For example, you are preparing H3PO2. So how you will prepare this? H3P. So phosphorus will have a double bond. Then two oxygens you are left with, and one H and one H here. This will be basically, first oxygen will be a double bond with the phosphorus. Rest of the oxygen will be OH here, and then you will have hydrogen, hydrogen, right? Rest of the hydrogen will be hydrogen, hydrogen. In some cases, you have POP bond also. Like here, you have POP bond. If you see this here, this structure POP, okay? This structure, it is a polymer of pyrophosphoric acid. Metaphosphoric acid is a polymer of pyrophosphoric acid. This has POP, this has POP. This does, rest of the compounds do not have POP. So whatever they ask you, let's say they ask you to draw the structure of H3PO3. How you will draw it? P double bond O. Now, one phosphorus you have consumed, one oxygen you have consumed, you are left with two oxygen, OH, and this will be OH. Now, how many hydrogens? Two hydrogens. You are left with one hydrogen, that will be H, right? But this is made from which thing? This is made from P2O3, right? Understood or not? Right? Now, next is, for example, they are asking, because you should know how to draw these structures. These reactions, they might or might not ask, right? That is still not very important. The reactions are not still very important. But to draw these structures, it is very, very important, right? Okay. So let us say you talk about H4P2O5. Okay. That is H4P2O5. So how you will draw this? Phosphorus with double bond, phosphorus with double bond. Okay. Now you have I'm so sorry. So here, if you see, you are left with three oxygens here. So let us say 1, this is 2, this is 3. Okay, OH, this is OH, this is OH. Now still you are left with 3 hydrogens, still you are left with 1 hydrogen. I'll draw it here. Now you are left with only nothing, P2O, 1, 2, 3, 4, 5. And hydrogen is 4, that is consumed. So we will just draw this bond here, right? Okay, understood or not, beta? Understood how to draw the structures, how to draw oxophosphorus, how to draw the structures of phosphoric acid. If any other structure you want me to draw, that I can draw for you, right? Because structures are not very difficult if you know the formula, right? The formula is important part here. Let's say they are asking you H3PO4, this we have already done. H4P3O7. H4P3O7. This has POP. Okay? This has this POP bond here. Right? So you have to draw it accordingly. Right? So this is P. This is P. There is one more P. Right? So if you, let's draw this thing. You have, I think it should be H4P2. Chalo, let's draw it. P double bond O. This is P double bond O, right? Then 4POH. 1, 2, 3, 4, right? Then there should be one. This is there should be one POP. So here option, the answer has become H1, 2, 3, 4. P2, oxygen is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it will be H4P2O7. This is not H2, H4P2O7. Let me just correct it. It will be H2. Okay, not 3. Got it? So it will be 2 only because 3 is not possible here. 3 is not possible here. So we have drawn this structure also, this also, this also, this also, this also, this also. This they will not ask you because this is a polymer. Right? Okay? Understand? Right? Beta, any problem here? The names, the formulas, the structures, this one, the oxidation state, these are very important. This one still you can ignore. This one you can ignore for JEE means, but for JEE advanced, obviously you have to go through this also. But for JEE means, you can ignore this. These 4 columns you should remember, right? Okay, understood? So I have given you a detailed portion of what they can ask you. They can ask you about the number of bonds. Okay, in they will give you some acid, oxo acid, especially for oxo phosphorus acids are very important, right? Now here you have, see, if you see this, this is nothing but this is Grignard reagent, and these are the carbonyl compounds, right? So how Grignard reagent react with carbonyl compound? It will react the same way. Okay, how Grignard reagent reacts? Grignard reagent is RMgX, okay, and this is the carbonyl compound that you have. Now what will happen? This is negative, this is positive. This will attack here, electrons will jump here, right? Same thing will happen here. Firstly, this is negative, this is negative, this is positive, positive. This one is negative, this one is negative, right? Firstly, this negative is going to attack here, this negative is going to attack here. It is going to make 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5. It is going to make a 5-membered ring here. Can you see how this negative is going to attack here? This negative is going to attack here. This is 1, 2, 3, 4, 5. It is going to be a 5-membered ring. Okay, it is going to be a 5-membered ring. On this 5-membered ring, if I see this is 1 position, 2 position, 3, this is 4, this is 5th. So what I can see that on the first position, there will be, let's say I am drawing it on the first position, let's say I am drawing it like this. On the first position, you will have 1 CH3 and 1 O negative that will convert to OH. Then on the third position, you will have 1 OH and there will be 1 CH3 here. Okay. Okay, so this is the structure that you will get. 1, 2, 3 on 1, 2, 3. Okay. So on this and this position, that means A is going to be the correct answer. So without solving also, we can answer this. Okay. I have not solved it in like entirely. We just know this concept that, okay, when R attacks here, electrons will jump here. This will be converted to OH. This will be linked here. Only we know is this concept. From this concept, directly we can answer the question here. Right? Okay. Next students, we have which statement is not true with respect to the nitrate ion test. With a nitrate ion test, which of the following statement is not true? Which of the following statement is not true with respect to the nitrate ion test? Yes, students. Very good. A dark brown ring is formed at the junction of 2 solutions. So nitrate ion test, definitely there is a dark brown ring that is formed here, right? Next is ring is formed due to nitroferrous sulfate complex. So what is the name of the complex? The brown complex is nitroferrous sulfate. This is iron H2 aqua. This is NO. So nitroferrous sulfate or this complex. Heating the nitrate salt with concentrated H2, light brown fumes are evolved. They are asking you which of the following is not true here. Yes, students, which of the following is not true? Better tell me which of the following is not true. If you see this here, this is the nitrate test with iron 2 positive, right? It will give you, this will be converted to Fe3 positive, right? After that, you will have the formation of brown ring, that is FeH2O aqua NO, right? So that means B is the incorrect option, right? Here you don't have nitroferrous sulfate. This complex is not formed, so this is the incorrect statement. That means it is the correct option, right? Okay. Next, students, we have the number of oxygen present in the nucleotide formed from a base that is present only in RNA. Tell me, which is the nucleotide, DNA and RNA? DNA, what you have? ATGC. In RNA, instead of T, you have a new thing. What is that new thing, everyone? What is that new thing? Instead of T, you have something else. What is that something else? Instead of T, what you have? Instead of T, what you have? Yes, students? Yes, that is uracil, right? So nucleotide formed by uracil. The base present in RNA is this one. Number of oxygen compounds in oxygen are 1, 2, 3, 4, right? That is attached with the phosphor group, right? Okay, 1, 2, 3 and 1, 2. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so total it is going to be 9. Nucleotide formed by uracil, the base present in RNA. In RNA, you have ribose sugar. So this is the ribose sugar. This is the phosphate group. This is the uracil that has 2 oxygens. So total it will be 9 oxygen atoms. Right? Next is the most common oxidation state. They are asking you the most common oxidation state of lanthanoid elements is +3. Which of the following is likely to deviate easily from +3 oxidation state? Cerium, lanthanum, lutetium and gadolinium. Yes, students? Which of the following is likely to be in some other oxidation state? So there are two major elements, that is cerium and europium. So this question they have asked even in JEE attempt 1 January, right? They can again ask you, this has been asked so many times, that cerium exists in Ce4 positive, this exists as europium 2 positive. This question is a very, very repeated question, guys. Very, very repeated question. Okay, yes, focus warrior, tell your friends about the channels and today's session, definitely, right? Because the more you tell other students about this, the more beneficial it will be for you, right? Why? Because the more energy you will see here, the more questions we can take up here, right? And that will help you only eventually, right? Okay, so share this among your friends and try to answer in the comment section. Okay, I would love to see your answers in the comment section. So answer is A is the correct answer. Now, very important thing for all the JEE aspirants out there, beta, this table should be by heart. Pick out all the shifts of attempt 1. You will see they have asked questions from this side, they have asked questions from this side, they have asked questions from this one also is very important. Samarium is also very important. Neodymium is also very important. So they have asked you question based on this. Lutetium was also very important, right? So they have asked question based on the electronic configuration of lanthanoids, which is a very, very, very important thing, right? So basically in the +3 oxidation state, gadolinium is stable and lutetium is stable. That is very important. And lanthanum is stable because 0 and half filled electronic configuration. That question is also very important. Next is the major product in the following reaction. So very simple. Firstly, you have to tell me what is the name of this reaction. Beta, this is a direct question. This direct question is based on, I'll just give you one hint. So this is basically when we break the double bond, we add OH and H positive. There are 3 things. One is acid catalyzed hydration where we use carbocation. Second is you have hydroboration oxidation where you use anti-Markovnikov rule. In this case, you have Markovnikov or anti-Markovnikov. You have Markovnikov rule. Okay, Markovnikov rule. So Markovnikov rule means on the negative side, negative part will be attached to less number of, let's attach it to more number of hydrogen. Okay, negative part to more number of hydrogen. So break this double bond here directly. You don't have to form any carbocation, nothing is there. So break this double bond, attach it. This will be CH, this will be CH2. So OH will be attached here. So answer is going to be, everyone, answer is going to be, wait a minute, Mark, by mistake I have written anti-Markov. Anti-Markovnikov ka by mistake I have written here, right? Yes, Markovnikov addition na. Markovnikov addition is simple, negative part to less number of hydrogen, okay? Anti-Markovnikov is negative part to more number of hydrogen. So this is less number of hydrogen. So OH will be attached here and H will be attached here. So this will become, this is CH2, or you can say this is CH, this is OH, this will be CH3. So answer will be, this is the correct answer. That is A is the correct answer. If you have hydroboration oxidation, then this would be the correct answer for hydroboration oxidation. Hydroboration oxidation. Okay, hydroboration oxidation, this would be the correct answer. That follows anti-Markovnikov addition. That follows anti-Markovnikov addition. Okay, so you have to see which addition they are asking you to do. Right, next is 40% of HI undergoes decomposition of H2I2 at 300. Okay, 40% beta, this means they are saying that you have alpha is equals to 40%. Okay, degree of dissociation is 40%. Delta G for this decomposition at atmospheric pressure is dash. Beta, here you have to find out the value of K, right? From that you will find out the value of delta G. Okay, because there is a direct relation of delta G and K. Delta G is equals to 2.303 RT log of Kc. So you have to find the value of equilibrium constant, then you can easily find the value of delta G here, right? Equilibrium constant, how you can find? This is Hi give rise to H2 half plus half of I2, right? So if you take 40% of this undergoes decomposition, if you take initial as 1, this is 0, this is 0. This is how much is dissociated? 1 minus alpha. Alpha by 2 is formed, alpha by 2 is formed. Okay. Now, if you see this thing here, this is also gas, this is also gas, so this is also gas. So Kp is equals to Kc in this case. Okay, Kp is equals to Kc. So you can just directly write down, these are the number of moles, right? So you can just directly solve it for the value of Kc, that is product raised to power the concentration divided by reactants raised to power the concentration. Okay, so how you will solve it? Till here we have done. What is the value of K? K is nothing but, what is value of K? K is products. Product is what? H2. H2 is alpha by 2 half. This is alpha by 2 half. I2 is also alpha by 2 half divided by 1 minus alpha 1. So half nothing but it is alpha by 2. This will be 1 minus 1 by 1 minus alpha. That is the value of K. Okay. Kp and Kc are equal here, right? Kp and Kc are equal here. So simply what you will do, put the value of alpha here. Alpha is given to be 40%. That means it is 0.4. Okay, so you just put the value of alpha as 0.4 here. Calculate the K value here. R is, we already know, 8.314. Temperature is given to you, I think that is 300 Kelvin, is it? Temperature is given to be 300 Kelvin, right? As you can see here, it is given to be 300 Kelvin. So just put the value of R and T here. Now, natural log is converted to log of base 10. So it will be multiplied by 2.303 and then you can easily solve your answer here. Okay, you can easily solve your answer here. Got it? Yes, everybody. Is there any problem? Any problem here? Any problem here? So simply what we did, we calculated the value of equilibrium constant. From that we calculated the value of delta G, right? Okay. Very, very important. This equation is this formula is very important. Okay. The equation of delta G and K, the equation of delta G and E naught, both are very important, right? Next is catalyst A reduces the activation energy of a reaction by 10 kilojoule per mole at 300 Kelvin. So you have catalyst A reduces the activation energy of a reaction by 10. Okay. The ratio of the rate constant K dash catalyzed and uncatalyzed is the value X. Assume that the pre-exponential factor is same in both the cases, right? you have to tell the answer here. So, beta dekho, you have two equations here. We know that k is equals to a e raised to power minus ea by r. Okay, they are saying for k dash that is uncatalyzed, this is a e raised to power minus ea dash by rt. Okay, so if you take the ratio k dash, okay, I'll take this as catalyzed, I'll take this as catalyzed, this is catalyzed because they have given na k dash is catalyzed, this is uncatalyzed without the catalyst. Okay, so you take the ratio k dash by k is equals to e raised to power minus ea by rt divided by minus ea by rt. Okay, so if you see this, you take the log here, you will have log of base 10 k dash by k, ee will cancel out, right? And hence the answer will be, this will be e, beta dekho, you can do one thing here, how to solve this. K dash by k, because I don't want you to cram one more formula. This will be E minus EA dash by RT plus of EA by RT, because this will be on the numerator. Take the log on both sides. Log of k dash by k is equals to, take the log base 10 here. This will cancel out, and here you will have, this will be minus EA dash by RT. This will be plus EA by RT. So directly what you can say, divided by RT. Okay, this will be EA minus EA dash. Okay, EA means it is uncatalyzed minus catalyzed. This they have already given to be 10 kilojoule. Okay, so what you need to do, you just need to put the value here 10 kilojoule, right? This R you know, this T you know, temperature is given to be 300. R we know that is 8.314. Okay, so then you can easily calculate the value of log of k dash by k. Okay, is e raised to power this, that will be e raised to power something. So beta, what you can do here now, what you can do here, instead of take the natural log here. Okay, you don't have to multiply this by 2.303. Okay, if you take the natural log. So natural log of k dash by k, let us say it is going to be x. Natural log of k dash by k, that is going to be x. Then the value of k dash by k will be equals to e raised to power x. So you have to find this value, that is x, that is 1 by RT multiplied by 10 kilojoules. Okay, understood? Yes, everybody. So you have to find this value. Same thing we are doing here. Natural log of this we are putting to be 10 kilojoules. Kilo means nothing but 10 raised to power 3. So kilo by kilo, we have multiplied it by 10 raised to power 3. This becomes 100 R, and this is the temperature. You got natural log of k dash by k as equals to 4. Okay, so that means k dash by k is equals to e raised to power 4. So answer is x is equals to 4, which is again a very important question. Okay, again a very interesting and very important question. This beta you must do. Okay, must do, because here this is a different question, and again this formula they are frequently asking. Even in attempt 1 they have asked question based on this formula, right? Next is given below are two statements. One is labeled as assertion, right? Other is labeled as reasoning. So you have to tell fluorine forms one oxo acid. Fluorine has smallest size among all halogens and highly electronegative. Yes, students. What is the correct answer here? Everybody, let me know in the comment section. Everybody, yes, it's not. Arey yaar, it is a live class. It is a live class, Power Studios, right? Okay. So, if you see this, fluorine forms one oxo acid, that is definitely correct, right? Okay. Fluorine has smallest size, that is also true, right? But if you talk about why fluorine forms only one oxo acid, the reason is because it is smallest size and it is highly electronegative. So many oxo acids are not possible for fluorine. right? So answer will be A is the correct answer, right? Okay, because of the small size, fluorine forms only one oxo acid, right? Next question is, in 3D series, the metal having highest M2 positive and M electrode potential is? Yes, students? Everybody? Yes, ma'am. Okay. In 3D series, the metal having highest M2 positive to M standard electrode. Beta, copper has a positive potential, right? That is why it is going to be the highest. So answer is C is the correct answer. Copper is the only element which has positive potential here, right? Copper is the only element which has positive potential. Okay? Okay. Yes, everybody. Next is everybody. Yes, very good, very good, very good. Ma'am, you are ignoring our answers. Acha, I am ignoring. I can't see your answers, yaar. You guys think ma'am is super magical, है ना? Something weird, magical powers I have in me to solve 100 questions, right? And also see each and every chat. Ma'am has 5-6 eyes, right? Is it? Ma'am has better only one eye. The F orbital are half and completely filled. If I have to do 100 questions, if I start chit chatting with you guys, na, then it will take us 15 hours, right, to solve 100 questions, right? 100 questions, even if we take 5 minutes with chit chatting, it will take us 500 minutes. So are you ready for 500 minutes? No, right? So that's why ma'am is only seeing those chats which actually I can see that, okay, you guys are answering in that. Okay? Yes, everyone? Yes, everyone. What is the answer for this one? Yes, students. Very good. Chalo. The F orbitals are half and completely filled respectively in the lanthanoid ions. Given atomic number is this. This is the atomic number, right? They are saying F orbitals are half and completely filled respectively in lanthanoid ions. Okay. So basically, if you talk about, I'll just show you the table directly here. Okay, I'll just directly show you the table here. If you talk about half filled and completely filled, TB4 positive is half filled. Okay. Then if you see this here, YB2 positive, right? This is 2 positive, right? This is fully filled. Okay. So answer will be TB4 positive and YB2 positive. This is half filled, this is fully filled. Okay, so this is what they are asking you. Half filled and completely filled respectively. This is F7 and this is F14. So answers that, this is what I told you previously also, that they are going to ask you questions from half filled, fully filled. Only they are going to ask you questions from lanthanoids electronic configuration. Okay, the configuration of the lanthanoids. Next is, if the initial pressure of a gas is 0.03 atmospheric. Now they are saying that if the initial pressure of a gas is 0.03 atmospheric, the mass of gas absorbed per gram of the absorbent is dash. Again, a very interesting question, right? So basically what they have given you here, this is the chart that they have given you, right? If you want to solve it, you can say that log of x by, this is y is equals to mx plus c. Okay, so y will be log of mx, m by x is equals to, slope is 1, x is log of p, right? Plus intercept here. If you see the intercept, c plus c is the intercept. Okay, so if I take, if the initial pressure of the gas is this, for initial pressure, we know that intercept is going to be 0. Okay, for initial pressure, the intercept is going to be 0 here, right? So that is why log of m by x is going to be log of p is the initial pressure, that is 0.03. Intercept is going to be 0 here. Okay, intercept is going to be 0 here, right? Now they are asking you the value here. वैसे the intercept they have given us to be C value, वैसे they have given us to be 0.603. Sorry, Intercept they have given to be 0.602. This is the intercept, right, for this general statement. This is x by m, not m by x. So this will be x by m. This will be x by m. Okay, this will be x by m. So just need to solve these values here. If you see this here, we can say the slope that is going to be 1, right? Value of k, okay? Log k, if you see the intercept here, right? Wait a minute. Wait a minute. Initial pressure is this, the mass of the gas absorbed per gram adsorbent is this, okay? Slope is given to be 1. If we compare this value, log x by m, this is y is equals to mx, slope is 1 only, x is log p, intercept is 0.603, right? So you can directly, you want to know the value of x by m, that is going to be your answer. Okay? To solve the value of log x by m, so if you take this, initial pressure they have given to be 1, slope is equals to 1. Okay? Initial pressure, the mass of the gas absorbed per gram absorbent is this. Slope is equals to 1. If we say slope is equals to 1 here, then if we compare this with the actual value here, if we compare this with the actual formula, then we can say this is the formula, right? Okay. So I'll just write the formula here, right? So that we can actually get the value, right? So from this, the formula, wait a minute, this will be log x by m, right? That is log of k plus 1 by n log of p. Okay? From this formula, if you take the log now, this is the formula that you will get here, right? From here actually, if we compare this with this formula, right? This is y is equals to, this is m, this is x, this is c. Okay? We can say then log of k is equals to 0.602, that is the intercept. 1 by n, that is the slope, is going to be 1 by n is equals to 1. Okay? So from this formula, we can say intercept y is equals to mx, m is nothing but slope, x is log p. From there, we can see the value of log k, that is the intercept, that is going to be 4. That means k value is 4. Slope also we got, that is 1 by n, that is going to be 1. That is given in the question only. Okay, this is given in the question only that the slope is 1 here, right? So from that, if the slope is 1 here, that means value of n is also 1, right? So value of n is also, they have given you 1. Now, if the value of n is also 1, the k value is also 4. From there, if you again pick this formula, right, you put the value of n as 1, right? Initial pressure is given to be 0.03. K is given to be 4, right? From there, you can get the value of x by m, that is 4 into 0.3, and initial value, order of the reaction is 1. So you can just put this and you will get 12 into 10 raised per minus 2 as the answer here, right? So basically, this is the formula that you need to know here. This is the formula that is important. Log x by m, that is the absorbent. X by m is equals to log k plus 1 by n log of p. You compare this with the straight line graph, you will get everything, intercept, the slope, right? After that, just directly from the initial formula only put the values, you will get the value of x by m, right? Okay, that is coming out to be 12 here, right? Okay, now next question is, in the structure of SF4, the lone pair of electrons in sulfur is in. Lone pair of electron of sulfur is in which thing? Equatorial position, lone pair, equatorial position, there are 3 lone pairs, axial position, this is what they are asking you. right? Again, for this, you need to know the structure of SF4. So anybody's sulfur is basically 6 minus 4, 2, that is 1 lone pair. So there is 1 lone pair, right? Okay, 3 lone pair, 3, 2 lone pair. Okay, chalo, theek hai. Let us see that. It has 6 outermost, 4 of them are already there, right? You are left with 2 electrons. That means you have 1 lone pair, right? Okay. From that, we can say 1 lone pair plus 4 bond pair, it is 5. That is sp3d. Equatorial position, there are 2 lone pair bond pair repulsion. Acha, lone pair bond pair repulsion they are asking. So this is sulfur 1, 2, 3, 4, 5. So you can see lone pair will be here. How many lone pair bond pair repulsions you will see? See, lone pair is on the equatorial position, right? So this is eliminated, this is eliminated. You can say there are 2 lone pair, lone pair, bond pair, lone pair, bond pair at 90 degree with each other. So answer will be A is the correct answer. So here you can say A is the correct answer. Okay. Next is among the following given oxidized oxides of nitrogen, the number of compounds having N bonds. So this is directly from the structure. That number of oxides having N bond here. So it is the option is N2O, N2O3, N2O4, N2O5. All of them, beta, they can also ask you the odd number of electrons here. This is what they have asked previously also, right? So as you can see here, this is N double bond, this is N double bond, N2O, N double bond, N this. So here it is N2O3 is NN bond here. N2O4 also has NN bond. N2O5 also has, it does not have any NN bond. So N2O, N2O3, N2O4 contains NN bond. This contains, this contains, this contains, this contains NO, N bond. So they can also ask you NO, N bonds also. Right. So answer is 3 of them has N2O, N2O3, N2O4 has the NN bonds, right? Next is which one of the following lanthanoids given below is most stable, right? Most stable, which of the following is most stable in divalent? So it's a very, very simple question, right? I expect you guys to answer this, right? So europium in the 2 positive state is very stable. Cerium in 4 positive state is very stable. Okay, these are 2 very, very important questions, right? Next is which of the following techniques is not used to spot components of a mixture separated on a thin layer chromatography plate? So, which of the following techniques is not used to spot components, that we can't spot components? I2 solid, UV light, visualization agent as a component of mobile phase, spraying of appropriate reagent, right? Which of the following is not used? Which is the following is not used? So I2 is used, UV light is used. So answer is visualization of agent as a component of mobile phase, right? There are stationary phase, mobile phase when we do chromatography. So when you do visualization agent as a component of mobile phase, that has not been used till now. Okay, right? Next is which one of the following component is inactive towards SN1 reaction? SN1 reaction, beta, it is a 2-step reaction. It has the formation of carbocation. Is inactive, that means which of the following? Carbocation is 3 degree, then 2 degree, then 1 degree. So in which carbocation is not stable, that is basically not applicable. So can you see this question again is a very, very interesting question. Here also you need to know core concept of one thing, that if you lose chlorine here, you will have a carbocation on the bridge head position. And whenever on this position or on this position you have positive charge, that is never stable. That is most unstable position. sp2 hybridized carbon is not stable at these 2 positions. So that is why this carbocation is not formed. So that is why this is inactive towards SN1 reaction. Beta, this is the active. This will be 3 degree, which is stable. This will be allylic, which is stable. This will be benzylic, which is stable. So all of them are stable except for C. Right, so answer is going to be C is the correct answer. Next question on your screen is match the following. You have to match the following, right? Emitted wavelength. Choose the most appropriate answers for the following lean. Okay, so here it is basically You're talking about energy is inversely proportional to the wavelength. Down the group, they are asking you which of the following is correct. Okay, down the group beta, they are asking you which of the following is correct. Yes, students, down the group, which of the following will be the correct answer? Anybody here? Anybody here? Hanji beta, down the group, which of the following is stable? Hint I have already given you, right? Okay, you have to see the increasing or decreasing order, right? Okay. Hmm. So this is down the group. If you see this down the group, here what will happen, right? Most appropriate answer we are saying, right? So energy is inversely proportional to wavelength, right? So basically, answer if you see, lithium is going to be, it is going to decrease, but rubidium will be the opposite one. So here it will be decrement. Lena is 670, 585, rubidium is 780, cesium, I think the answer should be A. Yes, A is the correct answer, as you can see. So firstly it is decreasing, then it is increasing, then again it is decreasing. Okay, this is what we can see with the lambda values. Okay, understood? Lithium, it is crimson red, so 670. Sodium yellow, 589. Potassium violet, 766. Again, it has increased, right? First, it will decrease. It will, see, from this to this wavelength, it is going to decrease, then increase, then increase, then again it will decrease. Okay, that is the change in the wavelength, right? Okay. Next, we have why I have taken up question based on color, because if you see in attempt 1, they have asked you I think 2 or 3 questions based on the color, right? From the coordination chemistry till now they have asked, so that is why color of the compound also becomes important for you, right? Next is which of the following component does not contain sulfur? Okay, which of the following component does not contain sulfur? Cimetidine, ranitidine, histamine, saccharin. Yes, students. So the answer is going to be histidine, right? So let us see what is histamine. So here you have nitrogen, nitrogen, a ring in which you have 2 nitrogen, like a pyrrole in which you have extra 1 nitrogen, and then CH2, CH2, NH2 attached to it, which does not contain sulfur. It has 3 nitrogens in the structure. 3 nitrogens in the structure, right? Okay. Next beta we have, next is C6H12O6 enzyme. You react this with enzymes, it gives A. Then with NaOI, it gives B plus CHI3. That means this gives iodoform test. Iodoform test. That means this A will have C double bond O, CH3. Okay? This kind of structure. So you need to tell me the number of carbon atom present in product B is going to be, right? This I have told you iodoform test it will give. That means methyl ketone should be there in the question, right? From there you can easily tell, even if you don't know the product A, even then you can tell the answer here, right? The product formed in B, right? So that will be which thing? Everybody? C6H12O6. That is reacted with zymase. Hints I have given you already. Now you have to tell me which is the correct answer. Everybody, Ashmit, Gamer, Jaina. Okay. Beta, why you are talking to each other randomly here? Hai? Whenever I see the chat, you are talking to each other randomly. I can't see the answers in the comment section. Where are the answers? Yes, students. Where are the answers? Yes, where are the answers? 2, 2, 2, 2, 2. Are you sure? Are you sure? Chalo, let us see that. देखो बेटा, first thing is what you are going to have. This can be either this ketone or it can be CH3, COH, and this is H. An alcohol, something like this, right? So if you see this thing here, beta, either to you should know the answer that C6H12O6 with zymase, what it is going to give, right? Either you should know the reaction. If you don't know the reaction, then what you can do here, right? You can do a guesswork here. Either it can be this ketone or it can be this alcohol. Both of them will give the answer. But whenever you react glucose with zymase, it produces alcohol, right? Okay, so it is not going to produce ketone. It is going to produce alcohol. So alcohol, only this alcohol is possible, right? That means you need to have that alcohol which is secondary in nature, right? And for this, you should know that you will have the formation of ethanol, that is CH3CH2OH, right? This ethanol falls into this category because only these two can give iodoform test, either this or this. Now from this you have the formation of ethanol which is going to give you the positive iodoform test, and whenever it is giving you the iodoform test, we know that in iodoform test you have the formation of two carbons here you have now, so this will be CH3COONA plus CHI3, that is of yellow precipitates. So if to confuse you more, they can also give you that there is formation of yellow precipitate. What is the answer? Right? So yellow precipitate means iodoform test. Iodoform test means either this or this. But if you have glucose with zymase, it is going to give you ethanol. Right? So answer is the number of atoms present in product B is going to be 1. So answer is going to be 1 is the correct answer. As you can see here, 1 is going to be the correct answer here. Okay. Next beta, next we have, consider the species. These are the species here: CH4, NH4 positive, BH4 negative. Option with respect to these species. They are isoelectronic and only two have tetrahedral structures. है ना? So if you talk about the species here, we know that this is tetrahedral, this is tetrahedral, right? Okay. So, okay. What about BH4? BH3 we know, right? When you add one more hydrogen into it, then because boron is electron deficient, it is going to accept the electron, so there will be a negative charge over there. Again, it is going to form tetrahedral species. Is it? Yes, everybody? But now to you must have seen the answer also. Now to tell me what is the correct answer. So when you talk about BH4, BH3 we know that is a trigonal planar. So BH4, that is also going to be tetrahedral only, right? Tetrahedral only. So answer is, this is also tetrahedral. So all are tetrahedral, this is eliminated. All have tetrahedral, this is also eliminated. All are isoelectronic or not, that you have to tell. Okay, so if you calculate the electrons here, this is if you calculate the electrons, this is 4 plus 6, that is 10 electrons. This is 7 plus 4 minus 1, again that is 10 electrons. This is boron. Boron is what? Hydrogen, helium, lithium, beryllium, boron. 5 plus 4 plus 1, that is again 10. So all are isoelectronic in nature. So answer is B is the correct answer. All are isoelectronic, all are tetrahedral in nature, right? Option B is the correct answer. Very good, very good, very good. Sachin, Ashmit, Bunny, very good. Okay, next is for the question here, for the reaction given below, you have to tell, you have COCl3.XNH3 AgNO3 if two equivalents of AgCl. Two equivalents of AgCl means two Cl are outside, right? Value of X. Two equivalents of AgCl precipitated out, then the value of X. Okay. Okay. Total you have 3 Cl. Okay. So NH3, what? Because cobalt will always have 6 coordination number, right? So this will be 5. So that means X is going to be 5. Okay. So CO NH3 5 Cl coordination number becomes 6. We have used all the chlorine and 2 AgCl will be formed here. That means the answer is going to be 5 is the correct answer here, right? Next is, which of the following combination gives benzaldehyde? Which of the following will give benzaldehyde? Any idea in the comment section which of the following will give benzaldehyde? So if you see this here, this is COOCH3 NH NaBH4 PCC SOCl2 pyridine H2PDBSO4, right? Okay, SOCl2, है ना? Then you use pyridine here. That means SOCl2 with the help of pyridine, that means you are converting it to COCl. Okay, this will be nothing but Rosenmund reduction. This is SOCl2 means this will be converted to COCl. So acetyl chloride with H2PDBSO4 Rosenmund reduction. That means we are converting this into benzaldehyde. So this is so definitely right. Okay, talking about NaBH4. Chalo, first you tell me this one. Toluene in presence of CrO3, right, and acid anhydride, that is just like, I'm not saying this is a Targe reaction, this is just like a Targe reaction. This will also give you benzaldehyde. Now tell me, NaBH4, will it give or not? This NaBH4 with PCC, that is a oxidizing agent, mild oxidizing agent, will it give or not? So what is going to be the answer? Everybody in the comment section. Everybody almost answer, so I have given you. If you are smart, then you could have answered this, right? Okay. B and C, है ना? Already we know that B and C is the correct answer, right? But why NaBH4 and NaBH4 PCC will not give this reaction, right? Because NaBH4, beta, it is a reducing agent, right? Okay, that does not react with acid or ester, so nothing is going to happen here, right? So that is the reason. Next is the correct order of basicity for the following compound, right? Basicity. Basicity is always dependent for all the students, beta. Basicity of amines is highly asked. It is dependent on availability of lone pairs, okay? Availability of lone pairs directly proportional to electron donating, inversely to electron withdrawing groups here. Okay? Check the availability of the lone pair. This is the lone pair, this is the lone pair, this is also the lone pair, okay? So now if you see this thing here, it is donating the electrons, it is not donating, it is withdrawing the electrons, it is giving the electrons also, and some electron withdrawing group is also attached here. So here you can see that ma'am, this will have maximum availability, so maximum basicity. So C is going to have maximum basicity, so this is eliminated, this is eliminated. Out of A and B, this is more electron withdrawing. That means electrons you are taking up. It wants to have more electrons. It wants to have availability of lone pairs. So this will be less. So A will be more as compared to B. So that is why C is the correct answer here. Is that correct or not? Is that correct? Which of the following compound is most basic? Everybody, which of the following compound is the most basic here? Very good. Most basic, if you see this, you need to have availability of lone pair. See, here though you have lone pair, but it is already involved. Here also you have lone pair. It is involved in two cases. One is this, other is this. Okay? This lone pair here, this is not involved anywhere, right? This is not involved in any mesomeric effect. This lone pair is involved in the delocalization and also it is withdrawing. So maximum will be B is the correct answer. Okay? Which is not involved anywhere, which is not involved in any resonance, right? So B is the correct answer. Because this is not involved in any resonance. Here you have, this is withdrawing, this benzene is withdrawing the electron. Here also benzene is withdrawing, plus the C double bond is also withdrawing the electron. Here benzene is withdrawing the electron. So that means you can see that only this is the case where benzene is not able to withdraw the electron. So answer is B is the correct answer, right? Okay, understood. Let me see how many likes for organic chemistry you are going to give. Hey, this much likes, why? This much so I had in my part 1. Before the class only we had around 45 likes, right? So what is this? What is this, beta? What is, right? That is not right. That was not ma'am's mistake that the studio was totally dead in between the class. So you can't do that, right? So you have to share this class. Carbylamine reaction is used for the detection of aliphatic 2 degree, aliphatic 1 degree, aromatic 1 degree. So answer is both aliphatic and aromatic 1 degree. So D is the correct answer here. Next is, what is the correct orbital diagram of a orbital designation of a electron with quantum number this? Acha. Quantum number is given to you, n is equals to 4. L is 3, S, P, D, 0, 1, 2, 3. That means here it is F, right? F means you have minus 1, 4F it is now, right? So correct orbital designation will be 4F, right? So answer is going to be B is the correct answer, right? Next, the total number of electrons that can be accommodated, that we are accommodated in all the orbitals having principal quantum number 2, azimuthal quantum number L. Principal quantum number 2, azimuthal quantum number is L, it is 1. FP 0, 1. That means we are talking about P. Total number of electrons in P, you have 3 boxes. So 1, 2, 3, 4, 5, 6 electrons. They are saying can we accommodate in all the orbitals? That will be total number will be if the total number is 6. Okay, if they ask you only 1, then that will be 2. They are asking you all, so that will be 6. Next is, for azimuthal quantum number, L is equals to 3, maximum number of electrons will be. For azimuthal quantum number, L is equals to 3, that means SPD 0, 1, 2, 3, SPDF. So we are talking about F orbital, right? Maximum number of electrons will be, for azimuthal quantum number L is equals to 3, maximum number of electrons that you can fill here in F orbital, beta, that is going to be, either you can just directly, achha, what is the formula? That will be 2L plus 1, that is the orbital. 2 into, this is nothing but this is F is 3, 4, 3 to 6 plus 1, that is 7 to 40. Okay, either you can do this, or you already know that in F orbital you have 14 electrons, right? So answer will be D is the correct answer, right? Next we have, which of the following is not permissible arrangement of electrons in an atom? It is not permissible, right? Okay, it is not permissible. Hanji, which of the following is not permissible arrangement of electrons in an atom? Not permissible. So always remember that n should be equals to 0 to, wait a minute. So L we write, L is equals to 0 to n minus 1. That means n should always be one step greater than n. N and L can never be equal to each other. L will be this, M will be equals to minus L to plus L. Okay, so from there you got the conditions here. If N is fine, L is 3, N is 3, 2, 3, 2, and this is also L 0. So all these are possible here, right? If L is 3, this will be minus 3 to plus 3, that is possible. It is 2, then M should be from minus 2 to plus 2. So this is not possible. So they are asking you not permissible. So B is not permissible here, right? B will be non-permissible here, right? Next is order of a reaction. Next is from chemical kinetics, right? The first order of the reaction, they are asking you, for a first order reaction, choose the correct value of half-life. You have to choose the correct value of half-life. What is half-life? T half is equals to 0.693, right? 0.693 divided by K. K is nothing but that is the slope, right? What is slope? Anybody? Slope is equals to tan theta, tan of 135 degree. Now here you will work on your mathematics, right? This is why this question is never asked in NEET. But this question can surely be asked in JEE. Reason being, because you're a mathematics student, they expect that you know trigonometry, you should know the value of tan 35. From there, you will calculate the value of slope here, right? Okay, so what you're going to do here, calculate the value of slope, that will be tan 35, that is equals to, if you see this thing here, log of our first order reaction, log of A is equals to, if you see A is equal, wait a minute, A is equals to, so I'll just write it here, K is equals to 2.303 by T log of 80 by A naught, right? So this you can write it as log of 80 minus log of A naught. Okay? So you can also calculate this as, this will be equals to, you can also calculate this as K, this is T, this is divided by 2.303. Okay, so you can also write this as K by 2.303, this is T. Okay, so this, if you compare this with Y equals to, this is Y. So if you take this here, so this will be log of 80, or you can say initial by final it is, na? Initial is A naught. Wait a minute. Log of A naught minus log of 80. If you see this here, this will be log of A naught na, A naught by 80. Okay? So it will be A naught minus log of 80. Okay? So if you take this on that side, if you take this on this side, so that will become log of 80 equals to log of A naught minus of K by 2.303 into T. Okay? From the formula, why I am asking you to derive it, because you can't learn these many formulas. Okay? You can't learn that this is the exact value. You can't do that. That will be very unnecessary things. Okay? So Y is equals to, this is M, this is X, this is C. Okay, so now if you see this here, slope is given to you. Slope is nothing but slope is equals to minus K by 2.303. So this is what we have written here directly. Okay, slope is equals to minus K by 2.303. Tan 35, 135 will be minus 1, right? Okay, then you can easily calculate 4, 5, 6, 7. This is 180. Basically, tan 45, those who don't know, little bit trigonometry I know, right? So tan 45 is equals to 1, right? So tan 180 is nothing but 185 minus 45. So that means it will be negative of that it will be minus of 1. Okay, it will be opposite of that because we are subtracting 180 out of it, right? So I think that is what I used to do 10, 15 years back, right, in trigonometry. So it's been long time that I have studied trigonometry, but this much so I remember, right? So directly you can put the value as minus 1 minus K 2.33, K will be equals to 2.303 per minute, right? So after that, if you know the value of K, you can easily calculate the value of T half. Putting this formula, you will get the value of T half here, right? Okay. So that also answer you can easily get. So two main things. One is you should know the knowledge of graph. Second is trigonometry is also used here. Next is the product formed in the following reactions. If you see this, you have toluene, you have added X2, Fe and dark. So they are asking you orthochlorotoluene, parachlorotoluene, what exactly you will get here, right? So you are going to do chloro. Now, so here you can add Cl2. Okay? You should add Cl2 then, right? Ortho product only you will get, para product you will get, or you will get both the products. Yes? So you will definitely get both the products here, but para being the major product. Okay? Para being the major product here. Next is X and Y are, they have given you X and Y. They are saying that X and Y are this. So if you see this, they are saying what is X and Y, that means this and that. Okay? So if you see this here, X is nothing but it is NaNO2. This is HCl, or you can add NaNO2 and HNO2. You can add. Okay. So this will be CO2, X2 you will add there. Okay. Chalo. I think this is actually I have given you simple halogen here. अच्छा चलो ठीक है. You have added NaNO2 and you have HCl here. So let's say HX here. This is nothing but diazotization at 0 to 5 degrees Celsius, right? So this will be converted to benzenium disonium halide. ठीक है? Benzene disonium halide. This is not correct. This is not correct, right? After that, once you have benzene disonium halide, so instead of HCl, you have added HX, so this will be N2X, positive, negative. After adding Cu2X2, that is basically Sandmeyer's reaction. This is converted to alkyl halide or aryl halide because this is benzene ring. So answer will be A. B is the correct answer. Okay. Those who have answered A, they are mistaken by this point. Alkyl, no, it is aryl halide. Okay, so you need to work on these silly mistakes. Okay. Next, students, we have what will be the product through SN1? SN1 means it is carbocation formation. Okay, so carbocation formation can lead to rearrangement also. So whenever you have carbocation, you have to think about ring expansion, ring contraction, ring and rearrangement. Okay, you firstly you tell me, will there be any rearrangement or not? Will there be any ring expansion or okay, tell me, I'll tell you, there will be ring expansion or ring contraction. You have to tell me whether there will be ring expansion or ring contraction. Let us see that. Okay, you have to tell me that whether there is ring expansion or ring contraction. Okay, ring expansion or something will happen here. But what will happen? Ring expansion or ring contraction? I told you a very simple trick. Right? Those who have studied GOC from me, they already know. But those who have not studied GOC from me, now I am telling you that thing. Right? Any student in the comment section, not even one student who can tell me ring expansion or ring contraction. Right? So there is going to be ring expansion. Whenever you have outside the ring, you have positive charge, there is going to be ring expansion. This is 1, this is 2, this is 3. So what you are going to do? You are going to join this, break this bond and positive here. Okay? So what we are going to do? We are going to convert this into, this is 2, this is C, this is, we are going to join this, we are going to put positive charge here, we are going to have this thing here. Now that is going to be our final solution, that is this kind of situation. Okay, then you are going to add OH here, that will be here. So answer is going to be A is the correct answer, is it? A is going to be the correct answer, right? Okay, you have this rearrangement, that will, you will add OH here and you will have A as the correct answer directly. Got it? Ring expansion, whenever what I did here, I just joined 1 and 3. Okay, simple thing is beta, you just join 1 and 3, break this bond, attach positive on second. Okay? Okay, students. Okay, next is what will be the product through this we have seen. One minute. What will the product through SN? Acha, this reaction, this is a different question. Okay, I didn't see that. Okay, I thought the same question is repeated again. Now here it is. Now tell me, will there be ring expansion or ring contraction? Ring expansion or ring contraction? Whenever on the ring, what I am saying, whenever on the ring, whenever dancing resonant beta, that is not this, you can't convert it into 3, right? So, okay, I got it, what you are exactly telling. Okay, dancing resonance, yes, that is in this kind of ring you will have dancing resonance. Okay, so here you have ring contraction or ring expansion. Whenever on the ring you have positive charge, there is a ring contraction. Again, same thing, 1, 2, 3. Beta, same thing you are going to do here. That is, you are going to attach 1 and 3. You have to attach them. Put positive on 2. Put positive on 2. This is the formation that you will have. I can say this is this kind of situation. You add OH negative here. This will be CH2OH. Okay? So answer will be C is the correct answer. Right? So C is going to be the correct answer. But without any break, I am going to do this. Reason being, I don't want to break the flow. Okay? I know not that many questions we are left with. Okay? So B here, right? B. I want to know in the comment section who guys are still there in the chat box, who are still ready to devote 1 more hour to this lecture, right? And who wants break, right? Because you will not get break in the exam hall, right? So you need to exhaust your mind at least now. At least now you need to exhaust your mind. If I am here hungry, I have not had lunch, like just like you, I am here just on water, right? So I'm still here. You can also eat something along with this, right? No break, nothing is needed. Okay, nothing is needed. Next is, which of the following pair of compound is enantiomer? Enantiomer means non-superimposable mirror images. You superimpose this. These are not even mirror images. These are diastereomers. These are not even mirror images of each other. These are also not mirror images. These are mirror images, right? Which are non-superimposable, right? Okay, these are also not mirror images. These are also not mirror images. These are also not. This is non-superimposable mirror image. So answer is B is the correct answer. Okay? These are mirror images. You paste it here. It is non-superimposable. So answer is non-superimposable mirror images is the enantiomer. Next is the work done during expansion. Now we have come to thermodynamics here. See how we are switching, right? How we are switching between the topics. That is very important for your exam. Okay? You need to switch between the topics. Okay. So here it is the work done during expansion of the gas from the volume of 4 to 6. Okay, 4 to 6. This is the volume, the work done during expansion of gas from volume of 4 to 6 against a constant external pressure is 3. Okay, so work done is what? Work done at a constant external pressure for isobaric processes. Simple, that is work done is equals to minus P external delta V, that is V2 minus V1, that is V2 minus V1. V2 is given to you 6 minus 4. P external beta. Now if you can see here, they are asking you from the gas, this is in joules, right? This is in joules. We know that because this pressure is given in atmospheric. Okay, I'll just write it here. This pressure is given in atmospheric. This is given in liters. So you have to convert atmospheric liter to joules. So you will multiply. 1 atmospheric liter is 101.32. Maybe this they will not give you in the exam. Okay? So if, I don't think so they will give you this in the exam. So if they don't give you this in the exam, you should know the conversion. That is, you can multiply simply with 101. Okay? So multiply this with 101. P external is given to you. Okay? This is 6 minus 4, that is 2. Okay? So you can just directly answer this with a very simple calculation. Okay? Next is the difference between, now they are saying the difference between delta H and delta U. They can also ask you the difference between heat. Acha, tell me what is the value of QP, what is the value of QV. Let us see how many of you actually remember this. What is the value of QP? What is the value of QV? What is the value of QP? What is the value of QV? I want to see that in the comment section. Difference between delta H, delta U. When the combustion of 1 mole of heptene is carried out at temperature T is equal to. Okay, so what they are saying, this is equals to delta H is equals to delta U plus delta NGRT. Okay. So delta Ng, if you talk about, you should know the reaction, that is combustion of 1 mole of heptene heptane, right? RT you don't have to know, you just need to know the value here, that is delta S minus delta U is equals to delta NG/RT. So all you need to know is the value of delta NG, that for that value, this value, see, it may seem that this question is from thermodynamics, but this question is a combination of thermodynamics and hydrocarbons. Okay, that is organic chemistry. Basically, you should know this generalization reaction from organic chemistry, that is hydrocarbons, that is C6H5 plus X plus Y by 4 O2, X of CO2, Y by 2 H2O, that is for your LK, right? So if you say that this is heptane, that means this is C5H 5 to 10, 12. Heptane है ना, it is 7. ठीक है, C7H14, 15, 16. ठीक है, C7H16, it is the answer. So X is 7, Y is 16. So you put all these values here, right? Put all these values here and you will get the answer, right? This is the reaction that you will get. Okay, this is in gaseous, this is in liquid, gaseous, and this is also in liquid. So what you will see, this is gaseous, this is gaseous. So product minus reactants, basically the mod of this will be 4, right? So just put the values here, product minus reactants. Product is 7 minus 11, that is minus 4. Put the value of delta Ng as minus 4 here, you will get the answer as minus 4 RT. Very good. Now I can see that QP is equals to, ma'am, delta H, Q is equals to delta U. Instead of this, they can also ask you what is the difference of QP minus QV. Okay, then students will get confused that, ma'am, they have asked, ma'am, QP minus QV. Ma'am, we don't have any formula where QP, QV is related to chemical reaction. This is how they can confuse you in the exam. Okay, yes, students. Very good, Sachin. Very good. Sachin was able to answer that. Very good. Okay. Next is the diatomic gas at pressure P compressed adiabatically to half of its volume. What is the final pressure here? Okay. So if V2 is equals to V1 by 2, this is what they are saying, a diatomic gas, pressure and volume. Okay, you have to know the formula, the equation of PV in form of gamma. Acha, tell me gamma for diatomic gas. Diatomic gas. If you don't know, degree of freedom is 5. So value of CV, if you don't remember the value of gamma directly, you can also calculate it like this. CV is equals to 5 R by 3. Okay? Okay. Then CV is equals to, CP is equals to 1 plus 5 R by 3. That 5, 6, 7, 8, 8 R by 3. Okay? So something like this will be there. CP minus CV. You can calculate the value of CP minus CV. For diatomic gas, directly you can see the value of gamma is 1.4. Monatomic it is 1.6 or 1.53 something. Right? So it is 1.4 for diatomic gas. So the value is PV gamma is equals to constant. That means P1 V1 gamma, P2 V2 gamma is equal. Right? So you can know that V1 is equals to half of V1, V2 is equals to half of V1. That is given in the question only, right? So here you can put the value of V2 in place of V1 and this is what you will get. V1 will cancel each other, 2 raised to power 1 by 4, right? P1 is equals to, P2 is equals to P1, 2 raised to power 1 by 4. So answer will be 2 raised to power 1 by 4. That is A is the correct answer. Okay? Understood? So the value of the relations of PV, PT and T and V, all of them in form of gamma are very important. The degree of freedom, or you can directly calculate the CV value or directly gamma value of monatomic, diatomic and polyatomic linear, polyatomic non-linear. Okay, all these are very important for you. Next is the work done during the expansion. The work done during the expansion of gas from volume of this to this against constant. This we have done. This we have done. This we have already done. Repeat it. For a given reaction, delta H and delta S are given to you. The reaction is spontaneous. Now, what is the equation? What is the equation here? Delta G is equals to delta H minus T delta S. This is also has been asked in almost all the shifts of attempt 1, right? Gibbs-Helmont equation. This is given to you, this is given to you. Temperature, if they are not given, acha, they have, basically they are saying temperature only you have to see, right? So you need to have delta G as negative. That means delta H minus T delta S should be negative. That means delta H should be less than T delta S. That means T should be greater than delta H by delta S. So just put these values and get your answer. Just remember, this is in kilojoule, this is in joule. So you have to multiply this with 10 raised power 3. Okay, then you will calculate the answer here. Right, so put all these values. Temperature is greater than delta H by delta S. 35.5 multiplied by 10 raised power 3 to convert it into joules, divided by 83.6, you will get it as greater than 425 Kelvin. Okay, next question is from thermochemistry. From thermochemistry, how the questions are asked? Either from Hess's law, or you should remember that from bond energies, always it is reactant minus product. These are the two things that you should remember. So given is C plus O2 has this, and CO plus O2 is this. Enthalpy of formation of carbon monoxide. Carbon monoxide is C plus O give rise to CO. That is the enthalpy of formation. CO of this will be half. Okay? That is the thing that you need to have. This is basically Hess's law only. How to get this equation here? What you will do is multiply this by half, then subtract it. This half will be this one, right? This will be CO plus, I'll just write it here. This will be CO plus half of O2 give rise to CO2. This will be C plus O2 give rise to CO2. Subtract, this is nothing but minus X, this is minus Y by 2. This is 1, this is 2. So what you need to do, 1 minus 2. Okay, do 1 minus 2, you will get this. 1 is minus X plus Y by 2. Okay, so that will be Y by 2 minus X. Okay, Y by 2 minus X, that is nothing but Y minus 2, Y by 2 minus X. If you see this now, you will get the answer because CO2 will be eliminated, right? It will be minus here, minus here, minus here. This will be half and this will come to this side, minus X plus Y by 2. Y minus 2X. Why I can't see any option here? Y by 2 minus X. D. How? Y by 2 minus X. Oh, this is the equation. Acha, they have taken LCM here. Y minus 2X by 2. Y minus 2X by 2. Okay. It was there in front of me only. I was looking at this thing, that why they have not given 2 here, why they have not given 2 here, they have given 2 here. Okay, so Y minus 2X by 2, that is B is the correct answer. Next is standard entropies. Next we have standard entropies, everybody, of X2, Y2, XY3 are this respectively. Now they are saying for a reaction of this delta H at equilibrium, the temperature should be. Okay, standard entropy for a reaction delta H is this, to be at equilibrium, temperature should be. But to be at equilibrium, delta G should be equals to 0. Delta G is nothing but delta H minus T delta S should be equals to 0. That means delta H is equals to T delta S. That means temperature will be delta H by delta S. What is delta H and what is delta S? Everybody, what is delta H and what is delta S? Delta H, if we talk about here, delta H is minus 30. So temperature is going to be minus 30. Delta S is what? This is minus 30 into 10 raised to power 3. Okay. What is delta S? Now you have to calculate the value of delta S here. Right? Okay. Now you have to calculate the value of delta S here. Standard entropy, this is given to you. This is the reaction. Half of x2 plus 3 by 2 of y2 give rise to xy3. Okay? So standard entropy will be, if you talk about this here, entropy will be product minus reactant. Product is what this? It has 60 minus reactant is half of x2. x2 is what? 70 minus 3 by 2 of y2. 3 by 2 of y2. y2 they have given to be 50. Okay. From there you will calculate the value of delta S. Now this is given in joule per Kelvin. Joule per Kelvin, joule per Kelvin. So that is clear. You will put this value directly here. You will get the value of temperature. Okay. You will put this value here as delta S. You will get the value of temperature. Okay. As you can see this also, right? So this will come out to be minus 50. You put the value here as minus 50 and you will get the answer for temperature. Okay. You put this here minus 50. Okay. This will cancel out and eventually you can answer this and this will come out to be 600 Kelvin. Okay. You can even see this that minus will cancel out. This is nothing but this is 3000 divided by 5. That will be nothing but 600 Kelvin only. Right? Okay. Understood? Everybody. Everyone in the comment section, is that clear or not? Now, magnetic moment, if you see this here, the magnetic moment 2.84 is given by. If the magnetic moment is this, I'll give you a simple trick here. For 1, it is 1.7, 2, it is 2.8, 3, it is 3.8, 4, it is 4.9, 5, it is 5.9. Okay. So here what you will see that here it is magnetic moment is 2.82. That means number of unpaired electrons should be 2. So you have to find out that value in which the number of unpaired electron is 2. Okay. So number of unpaired electron, one more thing that you should always remember. Sakti kar man fi ko ni ku jan. Okay. So that is nothing but 3D series that you should remember. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. So right here, this is 4s 3D, 4s 3D, 4s 3D. Beta, this is very, very important what I am writing now because this is going to solve almost most of the question. If you don't know this, then you won't be able to do 3D or you can say DNF block, or you will lose marks in VBT also if you don't know this. Okay, VBT is impossible without knowing the electronic configuration of 3D series. Okay, so here it is 21, 21, 22, 23, 24, 25, 26, 27, 28, 29, and this is 30. For 30 we will have 2 and 10. Now remember that for copper and for chromium there is new, that is 4s1 3d5, and for copper it is 4s1 3d10. Okay. So if you know these electronic configuration, you will easily be able to solve the questions here. So now if you can see this here, 2 unpaired electron will be there for which of the following, right? That means 2 unpaired electrons you need to have. So titanium 3 positive means you are going to have just 1 unpaired electron, right? Here chromium 2 positive means you take out 2 electrons, you are going to have 4 unpaired electrons, right? Then cobalt is this one. So you take out 2 from here, you are going to have 1, 2, 3, 4, 5, 6, 7, again 3 unpaired electron. 3 unpaired electron. For nickel, it is 3d8. You take out 2 electrons from S. 3d8, it is 1, 2, 3, 4, 5, 6, 7, 8. So it is 2 unpaired electrons. So answer is D is the correct answer. Okay? So why I wrote down everything here so that you can answer other questions related to this, right? So answer is D is the correct answer. Next is number of d electrons in Fe2 positive is not equal to number of electrons in which are one of the following. So Fe is nothing but it is 3d, 4s2, 3d6 because it is 26. Fe2 positive is nothing but it is 3d6, right? Because whenever you take out electron, you take out from 4s. Now, number of d electrons here are 6, right? Is not equal to which of the following? Okay. Number of d electrons in Fe2 positive is not equal to number of electrons in which of the following? Number of electron. Okay. P electrons in Z is equals to this, D electrons in Fp, okay. P electrons in neon. Neon is nothing but it is 1s2, 2s2, 2p6, okay. So in P you have 6 electrons, here also you have 6 electrons, here also you have D electrons, 6 electrons. S electrons in Mg can never be 6, okay. So here answer will be D, okay. Because see in S electrons will always be 2, right? Acha, wait a minute, S electrons in Mg, wait a minute, 1s2, 2s2, 2p6, 3s2, 3p6, it is 10, 11, 12, okay. So it is how many electrons? 1, 2, 3, 4, 5, 6. It also has 6 electrons, beta. 2, 3, 4, 5, 6. If you talk about chlorine, it will be 1s2, 2s2, 2p6, 3s2, 3p5. Okay, 5, 6, 7. Now the p electrons in chlorine are not equals to 6. Right, so answer will be A is the correct answer. Okay, p electrons are total 11 here. How 11? 5 plus 6, that is total 11 electrons you have. Here D electrons are 6 only. Here P electrons are 6 only. Here number of S electrons are 6 only. But here you have 11. So answer is A is the correct answer. Okay? Understood? Chal. Next is out of you have 4 species here. Right? They are saying the colorless species, that means either it should have, colorless means D0 or D10. Okay? D0 or D10 it should have, only then it will be colorless. There will be no DD transition. Right? So no DD transition, again it is same thing. Right? All of them, if you talk about Cu, this is positive, Ni. Okay. Everyone, tell me which of the following is, break, hungry. You can have bit of break. Tell me how many questions we are left with. Not that many questions, okay? We are not left with that many questions, okay? So I'll just, speed it up, right? So that without break we can complete the class, okay? Okay? Let's complete the class without any break. Why I don't want any break? The reason is it will break our flow of studying. Okay? Understood? Okay? Do you want break? Everybody? Everybody? Have no lunch, please. But even I had no lunch. Okay? I'm not asking you to skip lunch. Right? You can have something, you can have water, anything. You can also eat something. The side by side you are studying. Right? It will waste our time only. That time you can consume somewhere else. Right? Okay? Acha. Beta bangles, I'll tell you in the end. Okay? Why I'm wearing these bangles, I'll tell you in the end. But now you have to focus here. Okay? In the end, I'll tell you the secret of these bangles. Okay? Now see this. So you have to calculate the value of DD transitions here. If you see this here, titanium is in +4 oxidation state. Right here, cobalt is in +3 oxidation state. Copper is in +1 oxidation state. Nickel is in +2 oxidation state. If you see this here, +4 it is 3D0, it is 3D5, 3D10, 3D8. 3D10 and 3D0 will have colorless. So these two are going to be your colorless species. Okay, this question they have also asked in January attempt. The correct order of decreasing order of second ionization enthalpy. Okay, second ionization enthalpy, beta, they are asking you titanium, vanadium, chromium, manganese, right, from here. So if you talk about this thing here, the answer is going to be, let us see. So if you talk about titanium, that is 22, vanadium 23, chromium 24, manganese 25. One ionization energy, firstly let us write down the electronic configuration. First ionization energy, this is the outermost electronic configuration. First ionization energy means you take out electron from here, electron from here, electron from here, electron from here. First ionization energy is going to give you 3d5. This is going to give you 4s1 3d3. This is going to give you 4s1 3d2. This is going to give you 4s1 3d5. So maximum it is for chromium, right? Chromium will find it very difficult to lose one more electron because chromium is already in the half filled state, right? It is like if I lose one more electron, I'll lose this stability. So chromium is going to have the maximum. After that, you are going to have most difficult is, wait a minute. After this, if you talk about manganese here, right? If it loses decreasing order of second ionization enthalpy, right? Then if you see this here, this is going to be, because only thing that we have here is chromium. After that you have manganese, then vanadium, then titanium. Second electron in all these cases except chromium is taken out from 4s orbital, and for chromium it is taken out from half filled 3d. That is why it is going to have the maximum second ionization enthalpy here, right? Okay. Next is, which of the following pair are both ions colored? Both ions are colored in the aqueous solution. That means you should not have D0 or D10. It should not be there in the answer. D0 or D10 should not be there in the answer. Electronic configuration I have already written. You just have to write down the electronic configuration, beta. This I have already written. Who have just joined the class, but I have already written the electronic configuration here. Okay, so I'm not gonna write it again and again, right? So I have already written it there. Now what we are going to see, we are just going to see how to answer this question here. If you see this, scandium, copper, nickel, titanium and cobalt, all of them, the pairs are given to you. Scandium 3 positive means, wait a minute, because I don't like the electronic config, I don't write it like this now. So I'll just write it myself only. Scandium, it is 4s2 3d1. Okay, copper it is 4s1 3d10. Okay, nickel it is 4s2 3d8. Right, titanium it is 4s2 3d2. Right, cobalt it is 4s2 3d7. You take out electrons from here. Let us see. You take out electrons from here. For scandium, you take out 3 electrons, it will be 4s0 3d0. That is, it is colorless. It is colorless, no color, right? You take out 1 electron here, it is 3d10. Again, it is colorless. Colorless. Okay? You take out 2 electrons here, it is 3d8, which is showing color. It is, you take out 3 electrons here, it will be 3d1. Again, it will show color. dd transitions will be there. You take out 2 electrons, it will be 3d7. Again, the colors it will show because there will be dd transitions. Okay. So, scandium 3 positive and copper positive is not going to show you any, they are going to be colorless. They are saying which of the following pair are both ions colored in the aqueous solution. Okay. So, copper is colorless, scandium is colorless, this is colorless. So, only option left is nickel and titanium 3 positive. This is going to show you the color. Next is about the application, right? A very important question, match the catalyst with the process here. So you have to match the catalyst with the process, so directly you will see the answer only, right? So vanadium 2 oxide, that is then used in the oxidation of SO2 in the manufacture of H2SO, that is contact process. Okay, then you talk about this Ziegler-Natta catalyst. Okay, so Ziegler-Natta catalyst, beta, that is used in the polymerization. This is the last paragraph of coordination compound in your NCERT. In the last paragraph, This whole thing is given. Okay. So you see this. Second is used in the Ziegler-Natta catalyst is used in the polymerization of ethylene. Polymerization of alkynes, if you see, nickel complexes are used. PdCl2 is used in the oxidation of ethyne from ethanol. Okay. So that is the application given directly in your NCERT. The pair of compound that can exist together. Beta, the pair of compound that can exist together. Anybody. So pair of compound that can exist together. FeCl3 SnCl2, HgCl2 SnCl2, FeCl2 SnCl2, FeCl2 and Ka. That means they will not react with each other to form new compound. That is, both are reducing agent that will have no reaction on each other. If you see this, this is Fe2 positive. This is Sn2 positive, right? It would want to get converted to Fe3 positive. It would want to get converted to Sn4 positive because it is going to oxidize itself. So it is a very good reducing agent, right? So both are reducing agent. That is why they can stay in one solution as they are not going to oxidize or reduce each other, right? Okay. Next is the acidic medium H2O2 changes from Cr this to this. Kehta, in acidic medium, what happens? H2O2 changes H2O2 changes Cr to O72 negative to Cr to O5, right? Which has to this bond oxidation state of CrO5 is acha. Beta, this is a butterfly like structure, है ना? Double bond O, 1, 2, 3, 4. ठीक है, 1, 2, 1, 2, 1, 2, 3, 4, 5. So if you see this here, single bond means this is -1 plus 1, -1 plus 1, -1 plus 1, -1 plus 1, -2 because double bond, this will be +2. So total number is 1, 2, 3, 1, 2, 3, 4, 5, 6. So total number is, it is going to have, chromium is going to have +6 oxidation state. That is, C is the correct answer. Okay, because they are asking you about chromium here. So it is +6 is the correct answer. Very, very important. It has a butterfly-like structure. Okay. Next, we have the following ligand is, they have given you one ligand here. You have to see whether it is which kind of denticity. This nitrogen, this nitrogen, this oxygen, this oxygen. 1, 2, 3, 4. Okay. Can anywhere you can see any donating site? No. So it is tetradentate. That means here B is the correct answer. Tetradentate, B is the correct answer. Next, we have the coordination number of thorium in this is coordination number beta C. Oxalato has 2 coordination site and we have 4 oxalato, plus water has 1 site and you have 2 water, so it will be 2. So it is 4 to 8 plus 2, that is 10. So 10 is going to be the coordination number here. We are not talking about oxidation number, we are talking about coordination number. Next is, which of the following complexes are heterolyptic? That is more than one kind of ligand. So this is more than one kind of ligand. Second and fourth are heterolyptic. So B is the correct answer here, right? Next, the calculating magnetic moment. Everyone, I am speeding it up just for you, right? So I want you guys to answer that in the comment section, right? The calculated magnetic moment for species, this respectively is. Dekho beta, you have to tell the number of unpaired electrons here. Okay? Number of unpaired electrons you have to tell. So if you see Fe here, that is, you just have to see whether 4 or 5 unpaired electrons. Fe is 26, so that means 4s2, 3d6. Here it exists as x minus 4 is equals to -2, that is x is equals to 2 oxidation state. So in +2 oxidation state, it is existing in 3d6. Now, Cl is not a very strong ligand, so there will be no pairing here. So it will be 1, 2, 3, 4, 5. So no pairing means 1, 2, 3, 4, 5 and 6. So it has 4 unpaired electron. This is eliminated, this is eliminated. 4 unpaired electron, it means either it can be 4.9. So 4 means 4 point something should be the answer. Now let us talk about CO, CO2. So in both the option you have 0, 0. That means 0 is the correct answer. But still if you want to calculate, this is C2O4. That is the oxalato. Oxalato has -2 charge. So it will be X minus 2 multiplied by 3 is equals to -3. X minus 6 is equals to -3. X is equals to +3. Okay. So cobalt has +3. Cobalt is equals to 4s2 3d7. +3 means it will be 3d6. But oxalato is a strong field ligand. It is going to cause pairing. So it is 1, 2, 3, 4, 5, 6. Okay, this is how you will fill the d orbitals. So there is no unpaired electron. Talking about the last one, that is MnO for 2 negative. X minus 8 is equals to -2. For oxygen, the answer is -2. So it is X minus 2 multiplied by 4, that is -8 is equals to -2. X is going to be +6. Okay? If X is going to be +6, that means manganese, which has oxide, which is Karman, that is 25. So this is 4s2 3d5. +6 means all, wait a minute, bhai sahab. It is MnO +6, na? Acha. +6. Okay. So you take out 2 electrons from here, you will be left with only 1 electron in 3D. That is Mn +6. So it is going to show 1.7. That is, this is the correct answer. So C will be the correct answer. Okay, so that is how you are going to answer the question. Okay, next is the hybridization and magnetic movement of this and this respectively. Okay, first you have to tell the hybridization. Hybridization of this you have to tell. Magnetic movement of this you have to tell. Hybridization of this, either it can be sp3d2 or d2sp3. It exists in X minus 6 is equals to -4, X is equals to +2. Manganese is nothing but it is 4s2 3d5. For 2 positive, take out 2 electrons from 4s. So it will be 3d5. Cn is a strong ligand, right? So what will happen? It will cause the pairing. So it will be 1, 2, 3, 4, 5. This is S, this is sp3. It will cause the pairing. It will be 1, 2, 3, 4, 5. Okay? You will be left with D2sp3. So answer will be D2sp3. Okay? D2sp3, this is eliminated, this is eliminated. Right? Now, whether this is para or di. Next one is whether Fe CN6 is para or di. Again, X minus 6 is equals to -3, X become +3. Iron is 26. That means 4s2 3d6. Okay? Iron 3 positive is 3d5. Okay? Now, here what you will see, because Cn is a strong field ligand, is it? Cn is a strong field ligand. It will again cause the pairing 1, 2, 3, 4, 5, right? And you will be left with D2sp3, okay? D2sp3, and here you will have dimagnetic. Because it is unpaired electron there are na. So it is paramagnetic. It is going to be paramagnetic because you have one unpaired electron. So answer is B is the correct answer. Okay? Okay, understood? Okay, next one. Next is the correct order of intensities of the compound. Intensities of the compound, they are asking you intensities of the color of the compound. So if you see this, all of them are nickel, nickel, nickel. Strong, and the competition is with the ligand Cn, Cl and H2O. So you have to look for spectrochemical series here. We know that Cn is the strongest, right? Then you have water, then you have Cl, right? Now we know that lambda is inversely proportional, right? So we can say that the order of intensity will be this one because E and lambda are inversely proportional to each other. So answer will be opposite of the strength of the ligand, that is Cl, then you have water, then you have Cn. Okay, understood? So B is the correct answer. Next is oxidation number of potassium in the following. देखो बेटा, very simple. Peroxide, superoxide, and simple oxide. Okay, that is the answer. So if you see this, this is nothing but it is this is, if you see potassium now, this is peroxide. ठीक है, this is +2. ठीक है, and this is +4. ठीक है, so you can easily calculate this as well. 2x minus 2 is equals to 0, x is equals to +1. ठीक है, here it is 2x minus 4 is equals to 0, x is equals to 4, x is equals to 2. That we have answered. Third is x minus 4 is equals to 0, that is x is equals to +1. Okay, that is how you are going to answer for oxidation numbers. Okay, so either you can just directly remember or you can solve this also, your choice. Which amongst the following are good oxidizing agent? For good oxidizing agent, what you need to have? But I'll tell you in the end. For good oxidizing agent, if I'm a good oxidizing agent, right, I'll oxidize someone, increase the oxidation number of someone, I'll get reduced myself. I'll decrease my oxidation number, right? So, which is going to decrease its oxidation number, right? Which is more stable. So, this is going to decrease its oxidation number to cerium 3 positive because lanthanoids exist in 3 positive state. Is it? So answer is going to be this. Acha, D also na, C and D. D also we know that this TB4 positive is 4F7, that is why it is stable. But it is also because lanthanoids exist in +3 oxidation states, so it is also going to decrease its oxidation number and it is going to exist in +3 oxidation state, which is a common oxidation state for all the lanthanoids. In regular octahedral molecule MX6, the number of XMX bonds at 180 degree. Very simple this is. So this I have to show you with the help of the structure. So beta, they are asking you 180 degree. So this is octahedral. So this green to this red is 180. This green to this red is 180 degree. This green to this green is 180 degree. Total 3 180 degree angles you have here. So answer will be 3 is the correct answer. Okay. According to the molecular orbital theory, which of the following is true with respect to L2 positive and L2 negative? Okay, MOT. You have to solve it according to the bond order, right? So let us see the electronic configuration. If you talk about LIT, hydrogen, helium, lithium, right? Hydrogen, helium and lithium. Lithium is 3. 3 into 2, 6. 6 minus 1, array, it is not written, so I'll just solve it for you, right? So, Li2 positive, that is nothing but hydrogen, helium, lithium. 3 into 2, 6. 6 minus 1 is 5. Okay. Lithium 2 negative is 6 plus 1 is equals to 7. So, this is going to be sigma 1s. Okay. Sigma star 1s, sigma 2s, sigma star 2s. Similarly, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Okay? So here what you are going to do? 5, 2, 3, 4, 5, 2, 3, 4, 5, 6 and 1. Now talking about the bonding, anti-bonding, this bond order is going to be, bonding is 3 minus 2 by 1, that is nothing but 0.5. Here it is, bond order is, bonding is 2, 4 minus 3 by 2, that is again 0.5. Okay? So can we say that both are unstable? Right? Both will be unstable because if you have the bond order, see if bond order is 0, it does not exist. Bond order is 0.5. Then it is very unstable. If bond order is 1, 2, 1 means single bond, 2 means double bond, 3 means triple bond. Okay, so these both are unstable. Okay, wait a minute. Bond order, these both are going to be unstable here. Okay, so answer is not this. Okay, so it is coming out to be 0.5, right? Okay, hydrogen, helium, lithium, 3 into 6, yes. Okay, next students, let us see. Next one is, among the following molecules, right? Among the following molecules, which one is diatomic, diamagnetic, and has the shortest bond length? Dekho, O2 is paramagnetic. Firstly, let us calculate the bond length. More is the bond order, more is the number of bonds. See, if number of bonds are double. If you talk about single and double, single hand, this is single, this is double. Okay, I'll give you the comparison. Here bond order is less. Okay, so if bond order is less, then bond length is going to be more. That means bond length is inversely proportional to the bond order. So if you talk about the bond order here, simply you have to calculate this with the help of this simple trick, that is 14 means 3. Okay? So when you increase it 15, 16, 17, 18, you decrease it 13, 12, 11, 10, you have to subtract 0.5 from that. This is 2.5 to 1.51. 2.5 to 1.51. Okay, so here what you're going to do, this is, if you see this here, diamagnetic and shortest bond length. Now, so if you see this here, the number of electrons are, I'll just directly see, the shortest bond length means the longest bond order, the highest bond order. So this is 8 plus 8, that is 16. This is 14 plus 2, that is 16. This is 16 plus 2, that is 18. This is 12 plus 2, that is 14. So highest bond order, if you see, this is 3, this is 1, 16 means 2, and O2 also 16 means 2. Okay, so highest bond order is for this one. That means this has the shortest bond length. So answer will be D is the correct answer. Okay, so directly you can tell. Okay, directly you can tell that is D is the correct answer. Next we have constitutional isomer is possible in alkenes. Okay, only if number of carbon atoms. See, constitutional means structural isomerism in alkene is only possible, right? Like chain isomerism, all this is possible only if the number of carbon atoms, see if it is 3 carbon atoms. Then for alkenes, any constitution is not possible. How can you differentiate the structure? So at least 4 carbon atoms you need to have here, right? 4 or more. So answer is A is the correct answer. Next is, for the following half cell reactions, right? The correct cell representation would be. Let us see the cell representation here, everybody. Let us see the cell representation. Let us see the cell representation here. So if you see this here, this is basically, it is losing the electron. This is oxidation, that is anode. Okay. It is gaining the electron. This is the reduction, that is cathode. Okay, that is cathode. Okay. Always there have AC. AC means firstly anode, then cathode. So here this is automatically eliminated because firstly you will have anode, that is Fe, then you will have cathode. In Fe, the change is from Fe to Fe2 positive, Fe to Fe2 positive. So this is also eliminated. Here change is from Cu2 positive to Cu. So this we have selected. So B is the correct option. Okay, so we are left with B is the correct option. Always remember AC, anode, then salt bridge, then cathode. Okay. Given standard, so now what they have given us, given the standard E0 value, these are the E0 value. This is also a very important question. Okay. So standard E0, these are the 4 values given to us. Arrange these metal in increasing order of their reducing power. So if you talk about the reducing power, right, that would be inversely or directly. Okay. Acha beta, simple thing I'll tell you. If you talk about reduction potential, that means someone wants to get reduced. So reduction potential means itself getting reduced. It is oxidizing something else. So its oxidizing power is high. That means its reducing power is low. We are checking reducing power here. The one with the lowest reduction potential is going to have highest reducing power. Okay? All of them are getting reduced or oxidized. Here we have reduction or oxidation potential. Reduction potential, oxidation number will decrease. Here it is decreasing, here it is decreasing, here it is decreasing, here also it is decreasing. Plus to 0, plus to 0, plus 2 to 0, plus 3 to 0. That means it is decreasing. The number is decreasing. So all of them are reduction potential. Lowest reduction potential has highest oxidizing, reducing power. Lowest is this one, lowest, right? So it is going to have the highest power of reducing power. K, this is eliminated, right? Then after that you have Hg or Cr. After this you have Cr. Okay? So then you will have chromium, right? So answer is A is the correct answer. Minimum is for the highest. Highest is this has the highest reducing potential. That is why lowest reducing power. So A is going to be the correct answer. Okay, just remember this thing. Here you can also add one more thing. If reducing power is if reduction potential is high, then oxidation potential will be low. Okay, so this generalization is very important to answer these kind of questions. Okay. Then there is given the equilibrium. Let us see how many questions we are left with. Right, so very few questions. Acha, we are only left with 3-4 questions. Okay, only 3-4. Arre baap re baap. That means we have completed like 100 questions. That is a very great thing that we are able to complete 100 questions, right? So it's I think by 3 p.m. we'll be able to complete 100 questions. Okay, so given the equilibrium constant here, this is the equilibrium constant, this is given to you. Calculate E naught value of this reaction. So that means the equation between E naught and the relation of E naught and equilibrium constant, that is this equation. In Nernst equation only we have put E cell is equals to 0 and QC is equals to KC. Right? So if you see this N factor, you have to see this is given to you. Check it. KC is given to you. This is KC. You need to tell me the number of electrons here. If you see this, copper is getting converted to Cu2 positive by losing 2 electrons. Ag positive is getting converted to Ag, that too by gaining 1 electron, because 2 Ags we have to gain 2 electrons. So N factor is going to be 2. So just put the value here, that is N factor is 2 log 10 raised to power 16, because it is given to be 10 into 10 raised to power 15. So overall it will be 10 raised to power 16. Log of this is nothing but log of 16 into log of 10, which is equals to 1. Log of 10 is nothing but 1. So it will be 16 multiplied by this and you will get the answer. Okay? Okay. Understood? Chalo beta, next is which current? Beta, don't worry. All you have to do is give your 100% here. By taking so much stress, getting disappointed, you are only going to waste this attempt as well. Right? So be as confident as possible. You have some days left. Okay, we are also going to do some very important sessions for you regarding the mock test. So you should watch those mock tests, right? That is going to start from tomorrow only. Right, from tomorrow we are going to start mock test as well. So come in that session from tomorrow 10 a.m. we are going to start it. Right, join that. A lot of questions we will do there as well. Right, okay, so just focus here. I can guarantee all the questions that I have taken here, you will definitely see your questions will be around these questions only. Right, that's why I was very disappointed that why the first part was over. So those who have not watched the first part, go and watch that as well. Right, the first part was just for 1 hour, so go and watch that as well. It's a very, very important thing. Okay, yes. Now, what current is to be passed for 0.25 seconds for deposition of certain weight of metal which is equal to its electrochemical equivalent, that is Z. Okay, what current is to be passed? Current is to be passed for this, for deposition, this weight of the metal is equals to electrochemical equivalence. This you have to know. So weight is equals to ZIT, right? This we know from the formula. They are saying that weight and Z are equal to each other. Okay, this is what weight of the compound deposited is equals to electrochemical equivalent, that is Z. So you can also put the value of Z here. Z will cancel. You can know that I and T is equals to 1. Okay, so I and T will be equals to 1. Okay, understood? Wait a minute. Oh. Okay, looking very haunted here. Just give me a second. I know what has happened. But I think we shall continue the class. Is it? Do you want me to continue the class in this andhera? It will look like as if some bhoot is teaching you, but we are left with only 1-2 questions. Okay, so we can definitely continue the class. Right, 3-4 questions we are left with. Actually 5-6. Just give me a minute. I don't know what has just happened. Ma'am, electricity gone. Yeah, electricity gone. So sad about it. Chalo, let's see what we can do here. Okay, guys, do you want me to teach in this andhera? Okay, ma'am, anyways, let's proceed. Okay, so let's see the dedication of ma'am. Okay, so this is Z is equals to W and this will be equals to 1. So you will see some ghost is teaching you. So IT will be equals to 1. Okay, so current and time, for this what you will see that here time is given to be 0.025 and current you will solve here. So just put the value of time here, you will get the value of current here. That is the first question, right? Ma'am, board is visible. Only board is needed here. I am not needed here. Only board is needed. Okay. So current we have solved. Next is we have a direct current deposits 54 gram of silver during electrolysis. Right. So 54 gram of silver. A direct current deposits 54 gram of silver during electrolysis. How much aluminium would be deposited from aluminium chloride solution by the same amount? See, if you have silver, silver means Ag, that exists in Ag positive. If you talk about aluminium, that exists in Al3 positive. Here valency is equals to 1, here valency is equals to 3. Okay? So what will be the answer? It is from the Faraday's second law, that is the weight of Ag by weight of aluminium is equals to equivalent weight of Ag by equivalent weight of aluminium. Right? Now, if you see this here, a direct current deposit this much of silver. Silver deposit is given to you, that is 54. How much aluminium? This is what they are asking you. This is what they are asking you. Equivalent weight of Ag, we know that is equals to 108 by 1. Equivalent weight of silver, equivalent weight of aluminium is going to be 27. Weight of molar mass of aluminium is 27 and the N factor is 3 because it exists in Al3 positive, right? Aluminium, acha nahi. This will be, wait a minute, aluminium chloride, na, this will exist in Al3 positive, so this will be 27 by 3. Okay, so you put all the values, you will get the weight of aluminium here, right? Next question is, you will see, ma'am is not going to stop, beta. because you have your I can't delay these questions, right? What if any of these questions come exactly in your exam, then what you will do, right? So conductivity always increases with decrease in concentration of electrolytes. Second statement is molar conductivity always increases with decrease in the concentration. If you see this here, conductivity always increases. Conductivity means kappa, with always increases with decrease in concentration. Decrease in concentration means dilution. When you dilute something, concentration decreases. Kappa also decreases, right? But if you talk about molar conductivity, that is kappa into 1000 divided by molarity. So if concentration, molarity means concentration, if this decreases, molar conductivity will automatically increase. So kappa decreases, molar conductivity increases. This you should remember. Conductivity always increase with decrease in concentration, that is false. Molar conductivity always increase with decrease in concentration, that is true. So this is false and this is true. So answer is going to be S1 is wrong and S2 is correct statement, that is B is the correct answer. Next is, which of the following combination is suitable for preparation of 3-methyl-2-butanol? So let us draw the structure 3-methyl-2-butanol. Totally in अंधेरा है, ठीक है? So 3-methyl-2-butanol, you will see that, ma'am, this much board was never visible. Okay, 3-methyl-2-butanol, this is the structure, right? Now, we are saying that how you can form this, right? They have given you some different things here, that 2-butanol, acetone, this and that. So answer is C. How it is the correct answer? This is Mg, this is R. So this will be positive, this is negative. This negative will attack here. This will be converted to OH. So this will be CH3. This is CO negative. This is MgBr, right? This will be CH, then CH3 and one CH3 here. Okay? So that is going to be the final answer. OMgBr will be converted to OH. That is how you are going to have your answer. Okay, right? But we have some jugards here. Okay? There is, you need to ask this to Shreyas sir, है ना? Physics. Physics is applied there. For our studio also, physics is applied, right? So we don't want class to get over, right? Though I'm, oh my God, Bhagwan is like, okay, I'll be there. Okay. Yes. Chalo. Let us see. We have, I think this is the last question only. I think this is the last question only. Let us see that. 1, 2. Oh, we are still left with 3, 4 questions. Okay, chalo, no worries. Let us see. Here they have, here what we have is C double bond O, and this is C double bond O, this is H. Okay, C double bond O, this is H. You have OH negative, right? Plus you are heating it. Nee. Okay. Just trying to understand. This is OH negative or it is O3? Because the answer will change according to that. If this is OH negative, then this is basically your aldol or Cannizzaro reaction. If this is O3, then this is going to give you ozonolysis. Okay, reverse of ozonolysis. I think this is OH negative only, right? So we can say this is Cannizzaro reaction, where this does not have alpha hydrogen. This has alpha hydrogen. So this to has alpha hydrogen. Na? So what we can do here is, this is basically aldol condensation. Okay? This will be aldol condensation. How you are going to solve it? Let us see. Okay? So you have OH negative. What you are going to do here? Right? Pick out any alpha hydrogens here. Either this is also alpha, this is also alpha. So this alpha hydrogen, what a base will do, it will take out H positive and we will have a negative here. Okay, we will have a negative here. Okay, because base will take out H positive, we will have a negative. This nucleophile is ready to attack. And here you have benzaldehyde, which has C double bond O, and this is H. Now, can I say that this is the nucleophilic position? Okay, this is less electronegative, more electronegative. So this is going to attack here. Electrons are going to jump here. So what will happen? This is on this benzene. This is carbon, hydrogen. You will have OH here. Okay, because this hydrogen is going to attack here. This hydrogen that was eliminated is going to attack here. And we have OH. This hydrogen is already here. And this will be attached to the carbon here. Okay, to the carbon here, there will be one bond. And now you will have a pentagon in which the next position is double bond O. This is the answer that you will get. है ना? Benzene, then CH, right? Okay. After this, there will be condensation. Condensation means minus of water. So OH will be eliminated from this side, right? And hydrogen will be eliminated from this side. Okay. So double bond will shift here. So answer will be this is benzene. Okay. This is CH, which has a double bond here, right? Then you have a pentagon ring which has double bond next to it. Okay, so this is the final product that we have formed, right? So basically this is nothing but aldol condensation. Okay, this is nothing but aldol condensation. Got it or not? This is nothing but aldol condensation. Got it? Clear? Clear to everybody? Right? Okay. Now, next is in the following reaction, B and C respectively are. B and C, basically two things are given to us, LiAlH4 and NaBH4 with methanol. So here you need to be clear about one thing. What is the work of these two reagents? Okay. So here you have COO, that means ester group. This is ketonic group. It is very important that NaBH4 will not react with ester, right? So when you have NaBH4, right, that is product C, you are only going to reduce, product C is, this one is product C, this one is product C. So when you have NaBH4, that is product C, you are only going to reduce this double bond O, because both are reducing agent. LiAlH4 is also reducing agent, NaBH4 is also reducing agent. But NaBH4 does not reduce ester. It will reduce both ketone and ester. LiAlH4. So here what you will have, product C, this will stay as it is, ester will stay as it is, double bond O will be converted to OH. But in this case, LiAlH4, this bond will break, this will also get reduced to OH, this will also get reduced to OH, this will also get reduced to OH. So answer will be A is the correct answer. Got it? What is the main important thing? That NaBH4 never reduces NaBH4. NaBH4 never reduces esters. Okay, that is a very, very important point. Okay. Next is you have, which of the following combination is suitable for the preparation of 3-methyl-2-but? Wait a minute. 3-methyl-2-bu kya? Match list 1 with 2. Choose the correct answer from the option given below. Beta, acha. Okay, here it should be butanol. Butanol. Okay. So, which of the following combination is stable for preparation of 3-methyl-2-butanol? List 1 with list 2, correct answer of the given. Suitable for the preparation of 3-methyl-butanol. What is 3-methyl-butanol? Butanol means 1, 2, 3, 4. If you talk about on the second position, you have ol. Then on the third position, you have 3. 1, 2, 3, 4. Okay. So this is 3-methyl-butanol. Correct option you have to choose here. Wait a minute. I think two questions are mixed here. Two questions are mixed here. Two questions are mixed here, beta. Delete this because I'm not able to understand only that what exactly we want to say. Okay? Which of the following combination is suitable? Combination we don't have. Basically, by mistake, two questions and are intermixed with each other. So this is a different question. This is a different question, right? So that question you can eliminate, right? Because options they have not given us, right? So that question you can just eliminate. I'll just put black, black, black on there, right? Because this question is exactly not there. Okay? So here, what you have to know, this question is from inorganic chemistry, where what you have in the end, okay? What you have in the end, this is, that means 37 belongs to which one, 38, 78 belongs to which one, which one, which one. So all of this is in your, uh, I have to delete this. The question is incorrect, okay? So I'll just tell you what exactly we want to do here. Okay? So what we want to do here, now it is complete. Dekho. So basically, they are saying that this 37, it belongs to S block. Okay? 78, it belongs to D block. Right? C, that is 52, it belongs to P block. And D, that is your 65, that belongs to F block. Okay? That is the atomic number and its block. Okay? What you can do here, simple thing, I'll tell you here, simple trick. That is, if you have to calculate the block, that will be the last electron in which you have the last electron. If you have to calculate the period, right, you have to see largest value of n. Largest value of n. If you have to see group, for group also, because here they have asked you just the block. You can just write the electronic configuration. See, last electron is filled in what, right? But if they ask you the group, for S block, you will just see number of electrons in S. Okay? In outermost S. In last S. For P, add 12. No. Yes, add 12 plus number of electron in last P. For D, it is 2 plus number of electron in last D subshell. Okay, that is how you are going to answer this. Okay, this also becomes very, very important for you. Though right now they are not asking you as such questions based on predict the period or group. They are asking more about the trends, KMNO4, K2, Cr27, and more of electronic configuration of F block elements. Okay, this is how they are asking you most of the questions. Okay, so our target is complete. That is with so many distractions, so many problems, right? So many things in between. Still, we are able to complete our 100 questions. Okay. Those who have not watched all the questions, guys, there are two parts of this, part 1 and part 2, right? Watch both the parts to complete all the questions, right? Because in part 1 also I have taken around 20-25 questions I have already taken out. Rest of the questions I have taken in this part 2 because of some problem, right? The studio went off, so that's why I had to make the new session, and that's how we have part 2 here, right? Okay, yes, so we have completed this. Now I'll be doing some very, very small sessions for you. Tell me if you want it or not, right? So those sessions will be based on organic chemistry, inorganic chemistry, and physical chemistry. Very small session, hardly of 40 minutes. Hardly 40-minute session it will be there. Physical chemistry formulas, inorganic chemistry, important exceptions, and organic chemistry, will be entirely your naming reactions and distinguished test. These 3 sessions I'm going to take, right? And if you want to revise this more, right, okay, because you still have time, right? So if you want to revise this, so already things are going on in our batch, right? That is the crash batch. Day to night the classes are going on. If you want to see the see this, this is from 3 p.m. to 10 p.m. and it has increased now because we are very near to the exam. So the sessions have already increased, right? So that is why it is already going there. Full on revision we are doing from like 3 p.m. to 10 p.m. We are doing the revision. We are giving students the questions, the exact questions to practice, right? So here the questions that I have taught you here is just a glimpse of those questions that we are taking up in the batch, right? So live classes are there. Doubt solving is what we are focusing on in right now. Doubt solving, previous year question discussion, right? Practice question discussion. This is the major part that is going on right now. More focusing on the doubt session and the discussions, right? And rest of the things, handwritten notes, assignments, all these are already provided to you. But what is important for you right now is discussions, previous year practice question discussion, and doubt solving in the class. That is important for you, that we are doing right now, right? The batch will end at 20th of April. Then, ma'am, what we are going to do after this, after JEE, what we are going to do? So after JEE, we are going to focus on VIT Triple E in the batch itself, right? So if you are not sure about JEE, then you should also start preparing for VIT Triple E, because you still have more time for VIT Triple E. So this batch is focusing on two major areas, that is JEE and Triple E, VIT Triple E. Now here, if you are also very keen for KCT and COMED K, then with Crash Combo, we are providing you KC and COMED K test series as well in the batch itself, right? If you also want to practice the previous year question of physics, chemistry, and mathematics, right, then we are providing you with the printed JEE previous year question books delivered at your home. That is for Crash Pro, right? So I would advise you, depending upon what you are focusing on, you can purchase the batch. The prices are here, right? That is, it is now available at 999. Crash Combo is available at 1999. Crash Pro is available at 2999. Okay, so I would really advise you guys, all the students who are very skeptical about, ma'am, we are not sure whether we'll be able to clear attempt 2 or not. First thing is, you should get enrolled to this batch, so that in 10 days, next the remaining days that you are left with, you can, cover up maximum, you can utilize the maximum amount. And it's not like we are ending there only, right? We are saving your seat for VIT Triple E also, KC and COMED K also. So you should focus on those 3 tests as well, right? COMED K, KCT, and VIT Triple E, that will be covered in this batch only. The links are there in the description, so don't take any chance, right? Okay, that this is not the time to take any chance, right? So you need to have a good backup plan as well, especially if you're not sure about your JEE mains attempt 2. You need to have that backup plan, and that is why we are providing you Crash Combo and Crash Pro for your other things, right? Okay, that is why we have included VIT Triple E, KCT, COMED K in between this batch only, right? So you can go for this. Rest of the things are provided to you. If you want to purchase just the previous year question books, right, that is available at 999, right? Okay. Okay. 1 day tips to complete block chemistry in 1 day is, beta, go and watch. You can watch my lecture of block chemistry that I did in attempt 1, right? Okay, that is just 2 months back I did that, right? So you can go and watch that lecture where I have completed theory part in one section, block chemistry in one section. Go and watch that. It is hardly of 3 to 4 hour video with the questions. Go and do that, right? If you want to, right now you want to read NCERT, that is very difficult. But yes, I'm going to take up one very small session, as I told you, based on exceptions of block chemistry. Okay, all the exceptions of block chemistry I'll take in that only. Okay, now what about Bangle? Okay, so Bangle is that basically I'm from North, so I just got married 1 month back. So when a bride has to wear these bangles for 40 days, so that's why these bangles are there. Okay, so I follow traditions very religiously. So that is why the bangles are there. Okay, now is that clear? They are not going to ask you this in JEE, neither in VIT Triple E nor in KCT or Comet K. Okay, okay, then bye bye. Take care. Now, students, watch the part 1 and part 2 also. Rest of the things I'll provide you on my Telegram channel, that is t.me/Diksha Kaushal Chemistry. I'll just write it down here, right? And also on Vedantu official Telegram channel, I'll send the links. Diksha Kaushal Chemistry. Okay, this is my Telegram channel. Go and join this so that you can get the link of the next sessions that I'm gonna take for organic, inorganic, and physical. Very short, crisp sessions that you need right now. Okay. Okay, then bye bye. Take care. See you all in the next class, right? For your organic, inorganic, and physical chemistry quick revision. Bye bye.